So, good morning, everybody. It's Saturday morning, and I don't think it's the easiest time of the week for a symposium, but we're working on it. So, I welcome you to the 9th session of our symposium, and the title is Pigments. And the first presentation has the title Pigments and Technical Characteristics of Byzantine Mural Paintings from Eastern Crete, a diachronic overview of 8th to the 9th to the 16th centuries by Zafer Helvasi, Gulmini, Chiari, Cavalieri, Zervaki, and Giusteto. Please.
Good morning, hello. My name is Zafer Helvasi, and I'm a final year PhD student in the University of Torino. And I'm today going to present you the findings of my PhD research that we wanted to bring to this conference. So I have organized the project in the following manner. First, I will talk about the project a little bit, and then give a brief description of the wall paintings, and talk about my methodology, mention some results, and finally sort of try to contextualize them within the general scheme of Byzantine mural painting studies. So the churches that I have studied are from the Lassiti region of Eastern Crete. I have 11 churches dating from the 8th century to the 16th century current era. And this allows me to run a diachronic survey of the characteristics of both churches, their architectural style, and also the wall paintings and their characteristics, as well as, of course, the most important element, the pigments. So the wall paintings in general is very diverse. It creates a very diverse group of wall paintings. We have panels from the iconoclastic period. The one on the left from the 8th century is in Agios Nikolaos, in the church of Agios Nikolaos. The middle one is in Zeros. It's on the mountains in the plateau, and it has sort of a larger sort of a chromatic palette, more diverse pigments, but in moderation. And when we come to the 16th century, we also have a very different picture. So each wall painting represents a different characteristic. In this project, of course, the most important part is the characterization, but as well as this, I always wanted to contextualize the wall paintings within their architectural documentation. So all of the churches were surveyed and their architectural drawings have been created. This wasn't done before. And also where it was necessary, I did 3D modeling using photogrammetry. And then, of course, we took samples, we brought them to the laboratory for further analysis. And finally, I've been working on their contextualizing in art history and technical art history of Byzantine studies. So to reach these aims, we have the goals, like what we were trying to do, and as well as the characterization. It is hoped that all the data sets from this project will be sort of useful for other researchers in the field, but also sort of create a picture of this area of Crete in terms of wall painting characteristics. So the work was done in situ component. So the first part was documentation and the research planning phase, and then we took some equipment to the churches and then did some in situ analysis there, and finally the samples were analyzed in the laboratory in the University of Turin and the Centro Conservazione Venaria Reale and the University of Turin Department of Earth Sciences and Chemistry. So to talk about the methodology a little bit, when all the churches were documented, and sometimes it was impossible to sort of make measurements. So we used sometimes photogrammetry to get the shape of the building and superimpose these plans on the churches. So it was a very multidisciplinary research. And the portable XRF results, for example, we tried this SmartScan experimental software to be able to create distribution maps of the elements to see sort of not only the characterization, but how the pigments are, the spatial information about the pigments. And of course, the sample preparation allowed us to creation of a large amount of cross sections that created actually a database of the technical information. And not only for characterization, the cross sections were very important to show how these pigments were used. So it created sort of a more resolution of information, their place within the cross section matrix, and also, of course, the technique. So speaking of technique, overall, the wall paintings were sort of were made, executed using sort of a diverse set of techniques. We could sometimes see sort of signs of Acerco in carbonization lines on some of the cross section, meaning that the plaster was at an advanced stage or at a dry stage when it was painted. And in other case, they were painted a fresco. So we have a wide variety of techniques, but in all cases, in most of the cases, the pigments were embedded in a calcium matrix, indicating that as a binder, we of course expect organics as well. I did not do the organic component of the binders, but in organically speaking, I could say that the pigments were always mixed within a calcium matrix, probably lime putty or like a sort of a calcium containing binder. The reds were sort of was the most encountered pigment, so to speak, and they were manipulated in many different ways by mixing, by layering to reach a lot of different effects. Non-invasively, they were characterized using force. We were getting ochres and signals for cinnabar. And when we came to this stage after XRF and the force, we started to sort of get this resolution that we wanted in terms of information. So we could positively characterize hematite, vermilion, actually cinnabar, and lead red. Of course, these pigments are always different, sort of how much of, for example, cinnabar is the most expensive pigment. So how much of it is used and like where it's used, it always changes from church to church. There's a huge amount of variability. But one of the things that we know also from sources that lead red was kind of always mixed with cinnabar because it was a cheaper pigment. So they were trying to sort of use an expensive pigment and make it last a bit longer. So this was an economic decision from the painters. That's why most of the time, whenever there is a cinnabar layer, usually the lead red layer goes with cinnabar. Of course, there are exceptions. For example, in Panagia Kera in Kritsa, in this church, they went at the full expense. They didn't use any lead red. It was like pure cinnabar. So somebody really wanted to probably create an, I don't know, expensive painting. And when we did the characterization, the lead information is very low, almost like non-existent. It's there, but it's very low. So it was a pure use of cinnabar. When we go to yellows, the yellows were mostly used to emulate the gold effect. And again, we sort of non-invasively characterized, we see yellow ochres. And this was, of course, continued in the scanning electron microscopy to look at the individual grains and do also their characterization that gives us the iron signals. And this was a comparison of the single grains and also the chemistry of the pigment of the chromophore within the binder matrix. So this is a comparative elemental information showing that in one case we could locate one single grain of a yellow ochre, and then another case we could actually compare it to the how is the chemistry within the other part of the binder. For blues, it was mostly azurite, and sort of it was used in many different ways. On the top, you see it's in Panagia Kera. It was used for the veil of the Mother Mary, and but it's in a degraded form. But like when you do XRF or optical microscopy, it becomes visible. And then we also sort of corroborated this information with SAM as well. Also, blues are used as a part of the backgrounds. The one on the left is from Epanosimi in Ierapetra. Sort of because of the erosion of the black pigment, probably carbon black, the blue, the component became visible, and then the XRF also showed us copper peaks. And when we mapped the pigments in Ios Nikolaos in Zeros, we could also see that copper was sort of present in also the darker areas. When we come to greens, there are two options. One option is to create a mixture of yellow ochre with carbon black to create the visual effect of green. And this was, in a way, confirmed because the priests were bringing the candles too close to the wall. Sometimes there was the thermal degradation of the ochres. So this is, giving us another indication that there's an ochre there. And when I looked at a digital portable microscope, the goethite particles were sort of visible. And on the bottom, you can see the non-degraded and degraded cross-section of the sample from the green areas. In other places, it was possible to see the green earth and I'm presenting here on two occasions the examples of the green earth. And usually for this, the iron and the potassium are the pigments to look for to sort of the characterization. When we come to the skin tones, the type of pigments used do not change, but because of their different manipulation, different ways of creating the incarnatios were encountered. In the Church of Eponymini, it was a beautiful mixture. They created this perfect, amazing skin tone that you can see in cross-section here. And these are other examples from there. They were using the color, but also using the sort of the shadows, using whites, calcium white. And in other cases, this is a 16th century example from Zyros. They were using a sort of brownish, yellowish ochres and highlighting it with white to sort of to create this, so to speak, the chiaroscuro effect, sort of like darker and brighter areas to give the shadows on the face and the tones. And another example from Ios Nikolaos in Zyros, we see on the top left, we see an unmixed example of yellow, but for the skin tones, when they mixed a little bit of red and a little bit of sort of a black, a carbon black into the pigment mixture, creating the green effect to emulate skin tones. So there were many, many different ways of this. Again, these are two examples from a 14th century church in Ios Nikolaos that we see they could either layer it, mix it, or sort of within the same painting, there could be many different techniques used at the same time.
Excuse me, you have 5 more minutes.
Okay, for the whites, we sort of identified carbon, sorry, calcium, and also with we also checked it with UV fluorescence and UV reflecting features, and some cross sections for the white pigments, and sort of to be able to contextualize these wall paintings within the general scheme of Byzantine studies. I started looking at sort of to say like what is Byzantine characteristic, what is Byzantine art, and like how can we see this? So when we look at this at other sources, we know that the materiality of pigments play significant effect on the choices that artists made. But when we also look at Thompson says technical freedom is an illusion. So like it sort of talks about limitations. But when we start doing the technical studies in archaeometry, we see this type of deviations and sort of variability much more at the material level. So Dionysios of Furna is sort of considered as one of the sort of ground references for Byzantine painting. It is sort of quoted often, and in the recent scholarship, a lot of researchers started to look at Dionysios of Furna and see how the paintings can compare to this. In addition to this, what I have here is the Venetocratia, sort of the Italian Renaissance influence. And here I would like to bring to your attention two samples from a very in close proximity, both executed in the 16th century. But when we look at their pigment chemistry and type of pigments they use, they are very different in addition to how they were executed. So in addition to the characterization of what constitutes Byzantine painting, it's also important to see how interactions play between Renaissance Italy during the Venetocratia period, both how Crete is affecting Venice, but also how the Venetian influences can be manifested on this part of the world, if they can or can we see it? It's one of the research questions that I'm very interested in. In the end, what I can say is that the chromatic palettes encountered are in sync with textual sources and archaeometric literature. And there is high degree of variability in terms of technique and pigment recipes over the whole survey. And we can start to see Venetocratia and Italian influences on at least one of the paintings. In Voila is a testimony to the diversity of artistic production and technique in the region. And what I believe that I have created a comprehensive data set from a very geographically focused area. I think there are some studies from Cappadocia that we can see in ICROM at the moment, so we can compare these, that I was also working as a fellowship with them. And also sort of results and conclusions allow the construction of a bottom-up perspective. So rather than seeing how Byzantine paintings should be like, we can actually start sort of discerning the characteristics of what we have here, and then sort of contribute this information to the general understanding of Byzantine arts. And thank you very much.
Thank you very much for a very comprehensive presentation. Are there any questions? Questions? No? I have one. I saw in some of your slides in the stratigraphy of colors, for instance, in the red, there were layers of red. I mean, is this a type of pattern that the artists or some of the artists followed?
I understand.
Yeah.
Yes, in a way, yes. There is a pattern. Usually, what I feel, what I see is that the ochres, the hematites, is the main. It's the workhorse. It is the main pigments that they use, and then they can try to modify the color. But usually, because the cinnabar is the most expensive and most sort of glamorous, most precious pigment, it usually goes on the top. So there are some patterns, but when we, for example, when we sort of think about a pattern until the 16th century, and by the time we go to Voila, sorry, let's go. I hope you can follow on the adapter. Sorry for this. So when we go to Voila, so on the top left one, you can see that sort of.
We can't see anything.
You cannot see my presentation screen?
It's not shared.
You actually need to share your screen through the Zoom platform.
Okay, let's try one more time. Let's try one more time. Okay, share. Can you see now?
Yes,
Yeah, yeah.
yes.
Okay, so this is the sample. It's this comparison of the two 16th century paintings. The one on the top left, you can see a darker red superimposed by a brighter red. But when we go to Voila, to another, the one that I said has maybe Renaissance Italian influence, we see that actually cinnabars could be used for like layers under as well. So it is very variable. There are sort of patterns, there are sort of ways in which it's executed, but it is very diverse.
Right. Okay. Thank you very much. So I guess we don't have any more questions. So thank you very much.
Thank you.
The next presentation is titled The Mural Painting Study of the Church of St. Andrew of in Peristera, 15th to 19th century, Thessaloniki, Greece. This is by Vivdenko, Tsiapali, Vasiliadou, Stamkopoulos, Protopresbyter, and Zacharias. Please.
My name is Labrini Maletsidou, and I have a last-minute representing of Svetlana Vivdenko because of some problems she encountered. I'm currently a research associate in Athena Research Institute and a postdoctoral researcher in Aristoteles University of Thessaloniki, and I'm now trying to start make some secondary progress on the same set of samples. So for this reason, as this was a last-minute call to represent this presentation, I will be quite shortly, so let's start. This work is dealing with the results of examination of the frescoes of the Church of St. Andrew in Perisτερά, Thessaloniki. So in this picture here, we can see the church after its restoration. In its original form, the church is believed to have been an early Christian martyrdom dedicated to St. Andrew. On its ruins, the monastery of Perisτερά was built in 870 by St. Euthymius. Modern archaeological research has revealed three successive chronological phases of construction. These are the first one, the basilica from the early Christian period. As a second one, we have the Tetrakon's church from the Middle Byzantine period. And thirdly, we have the face of the now existing church, which was built during the post-Byzantine period. So these slides show the sections of frescoes of the 12 apostles in the dome of the church. And we have also on the left one, the apostles Peter and Paul holding a model of the church in their hands. A moment. So, in August 2015, the church unfortunately was damaged by a fire incident caused by worsened the already poor condition of preservation of its decorative and structural elements, as you can see in the picture above. Over the past 5 years, under the supervision of the effort of Antiquities of Thessaloniki region and under an SRF project funded, restoration and conservation works were carried out, resulting in the full restoration of the church, which was reopened full functional for rituals in December 2021. During the restoration and conservation works, the contribution of physicochemical analysis was invaluable. After examining the church's building materials, both original and from previous interventions on the church, and identifying over 10 different mortar compositions, the appropriate materials were selected for the restoration work. So, as you can see, we here the church after restoration, after the fire, after restoration program. The analysis of pigments and the underlying layers significantly helped clarifying issues of distinguishing the wall painting decorations. From the examination of the painting decorations, we can distinguish at least 5 different types of wall painting and distinguish between one another by their morphological features, the applied materials, such as pigments, and the applied technique. These phases, no, they're not phases. These cannot be named as different pictorial phases, but more something like overpaintings, as the church has been active continuously since the 15th century until now. So the first one, what we call the first wall painting type, was identified fragmentally on the northern wall of the church. We have some small fragments here, which were complete decomposition of the organic fibers in the ground layer was observed. From the overall assessment of the examination results, it is determined that this is the oldest plaster with color in the church's decoration. The surface has a pale yellow base where the mineral goethite of yellow ochre was identified, and it retains traces of red decorations where the mineral hematite of red ochre was identified. These samples, we can say that these samples correspond to the earliest fresco phase of the monument. And as the second phase of fresco, wall painting, this is relating to the painting located above the door of the side chapel of the Iconicon, where full-length saints and the scene of waiting of souls was depicted. In the center, in this slide here, we have a schematic drawing of the psychosis scene, which was created by Mrs. Mavropoulou. In this case, and in this second phase of wall painting, the second type of wall painting more correctly, we encounter the palette of ancient pigments, such as red and yellow ochre, mixed, in this case, unexpectedly, with yellow orpiment and cinnabar. Notably, in the same depiction, in the overpainting layer where blue is used in the folds of the saint's garment, A later artificial ultramarine was identified, which was firstly manufactured in the beginning of the 19th century. The blue pigment of the artificial ultramarine was applied over a thin layer of lead white, which covered the original yellowish to reddish color of the garment itself. The white base of the new layer, covering the darker color of the garment, enhanced the brightness of the ultramarine. The third wall painting type of the church is related to the paintings revealed on the inner arc of the eastern part of the central dome. In this frescoing phase, the blue outlines of the figures with primary pigment being artificial ultramarine again. Apart from ultramarine, two other pigments were used, very sparingly, we should say that, very sparingly, in the blue fresco of the third phase, such as the one with birds, where red lead and chrome yellow were spotted. The latter was manufactured in the beginning of the 19th century also, and since then it has become a popular pigment widely used in various painting techniques on different substrates. So the third type of wall painting may be associated surely with the beginning of the 19th century. Again, in the third type of the wall paintings, it is also included the decorative coloring of the church pillars with artificial ultramarine and, surprisingly, emerald green. This remarkable green pigment has been produced industrially since the beginning of the 19th century, starting in its second decade. The fourth phase of wall paintings, the fourth type of wall painting is found in the decorative dome. Again, artificial ultramarine is used in two ways this time, either as the main pigment, for example, to create the blue background in the hemisphere, or as an overpainting again. It is worth noting that the overpainting in this case, unlike the second phase of the overpainting, was applied directly on the brown colors of the garments without the use of an intermediate white layer or a new white preparation. This results in a darker blue color rather than the bright one that was observed in the same garment, the second phase, the second type of wall paintings. Finally, the fifth wall painting type is associated with the use of organic pigments, and in this case, only the reddish one was identified so far. The work is still going on. In this case, those pigments were identified in the outer perimeter of the western lateral arc, featuring a decorative motif with rhomboids. Analysis has shown that this is an organic rose-colored pigment distributed over grains of calcite. It is identified using HPLC as a synthetic organic pigment named beta-naphthol, which was produced in the last quarter of the 19th century. So, for the conclusions, based on morphological and state of conservation and other characteristics, we have 5 distinctive pictorial types, which are not found in the integrity of the church and the wall paintings that have remained, but they are mostly locally spotted. So we have identified those, and the work is still going on identifying more pigments like the green one, the last one of the fifth type I have shown you. And of course, we're trying to find out something about the probable use of organic binders in each one of the layers, of these layers. So that's all, and thank you for your attention.
Thank you very much for keeping up with time and for a very interesting presentation. So, questions? Any questions? I have a couple.
Okay.
The first question concerns the deterioration that we saw on the paintings. Maybe I missed it on your presentation, but they exist before this late fire, or is
Yes.
existed? Yeah.
Yes, they existed. And as Dr. Vivtenko told me, they have collected some samples in the form of grains of about half to 1 millimeter just before the fire, in some cases. The temple, the wall paintings were in very bad kind of preservation.
Okay. And the second question concerns some of the pigments that you presented us, especially for synthetic ultramarine blue. What evidence do you have for that?
About the synthetic type of its pigment.
Of course.
Of course, it's all the hot question regarding ultramarine. So, identified as a synthetic one because of its morphological characteristics, because of its grain size. Apart from that, during using the polarizing microscope, showing special characteristics, and all are according to synthetic ultramarine, not to natural ultramarine. We don't have any irregular grains, we have accumulations of grains. We also have very, how to say it, we don't have different grains we don't have grains of different colors, like in ultramarine, like in genuine ultramarine from lapis lazuli.
Right. But generally, artificial ultramarine was introduced somewhere in the middle of the 19th century. It coincides with the time frame of what you have already documented in the paints and the overpaints.
Yes.
Does it go along with that?
Yes, that's the reason the work is still undergoing, to try to find out maybe which kind of wall painting was one on the top of the other, just to find out what is going on with the chronological time frame of them.
Okay, I see. So thank you very much. If we don't have
Very
any more
welcome.
questions. So thank you very much. And I'm going to invite Nicoleta Nicolaidou to present Seeking the Unseen, a non-destructive investigation of an overpainted panel painting by Nicolaidou, Asvestas, Kaminari, Panou, Sambatakos, Anagностopoulos, Alexopoulou, and Mastrothodoros.
Can you hear? Okay, thank you. Good morning, everyone. Today I will be presenting the findings from a detailed study and documentation of post-Byzantine religious portable panel painting that has undergone significant overpainting interventions. The research focuses on analyzing the current state of preservation of the artwork using advanced imaging techniques like macro XRF and IR reflectography. This work aims to uncover hidden layers, and in particular, the remnants of the original painting, as well as to help us understand the extent of previous restoration attempts. In the framework of Eastern Orthodox Christian Church, worship, the religious panel painting are referred to as icons. These artifacts are intrinsic element of Orthodox worship. Therefore, thousands of icons are spotted in churches, museums, and private collections. Although over the time, we do observe changing in the stylistic features of icon painting. But it's interesting to know that in terms of manufacturing, materials and techniques, their technology remains consistent during the last several centuries and resembles that of typical medieval panel paintings. The subject of the current study is rather peculiar icon of Christ Pantocrator, originating from a private collection in Skiros Island. The painting measures 65 by 45 by 3 centimeters, and on the first sight, it's obvious that it has suffered severe deterioration and undergone extensive repair interventions. An initial assessment of the stylistic features of the work suggests that it was created by non-particularly talented folk artists of 20th century. However, through careful macroscopic observation, we identified certain areas of painting that show substantially dividing features that are consistent with a much higher level of artistry and are likely for considerably earlier period. Two characteristic examples are Jesus' left hand that holds the gospel and the left part of his face, in particular hair and the eyes. These make it clear that the work bears at least the different phases of painting, and it's obvious an overpainted icon. The overpainting is a term used to refer the application of new paint layers over an existing work. These new paint layers are usually applied over a dedicated painting that has suffered from discoloration, paint loss, or other types of damage. One of the major challenges when dealing with such icons is to determine the extent of the surviving original paint and to identify which parts correspond to later interventions. The observation areas preserving paintings that corresponds to significant and much older artwork that stimulated through study of the icon, but using exclusively non-destructive techniques. This aims primarily to determine the extent of preservation of the original paint layer and to access its condition, which are the main research objectives of the study. More specifically, the study aims to identify the extent and condition of the original painting, document the current state of preservation of the icon, reveal the materials and techniques used both in the original work and later interventions, and map the areas that have undergone prior interventions. To tackle this issue, we employed exclusively not invasive techniques such as photography under direct and under raking light, multispectral imaging and infrared reflectography, UV fluorescence, X-ray radiography, and X-ray fluorescence spectroscopy. The employment of these complementary techniques allowed for a thorough investigation of the painting and return data that may eventually lead to the identification of particular pigments and painting materials, as well as the distinguishment between the original painting and later additions. Photography under raking light revealed in a great detail the surface topography of painting and allowed for assessment of its current state of preservation. UV fluorescence imaging help us identify the areas of overpainting, particularly around the Christ's right hand and the region of the halo. Additionally, a rather intense greenish fluorescence highlighted the distribution of varnish, which is especially visible around the eyes, indicating incomplete varnish removal attempts. Infrared reflectography allowed us to detect painting layers that lay below overpainting, especially in Christ's face and hair, suggesting the existence of a far more detailed original composition. We also identified the different lettering beneath the visible overpainting on the gospel, confirming that the works has undergone past restoration interventions and completely covered original elements. The X-ray radiography provided a clearer view of the underlying structure, revealing the presence of incised preliminary underdrawing, not visible to the naked eye, particularly around the face and the book. The X-ray also revealed a different, obvious, older outline of the book beneath the overpainting, differing in size and shape from what we currently see. Additionally, this method revealed important technical characteristics of wooden panel, like presence of metallic nails to attach the crossbars. Lastly, the X-ray radiography revealed hidden details, like the small circular details on Christ's stomach and a fine painting on his face, indicating that the icon was originally much more richly decorated than it currently appears. This evidence speaks to a high level of artistry involved and significant changes the icon underwent over time. From the results of macro XRF analysis, we dedicated various chemical elements that pertain to modern synthetic materials and suggest extensive overpainting. Barium, zinc, and titanium were identified, particularly in the tonic, and the background indicated the use of synthetic pigments and in the framework of recent restoration efforts. This helped us to highlight the areas where modern intervention had taken place. Also, analysis uncovered that the intensity of calcium is maximized in areas of paint losses, likely due to the filling the missing parts with calcium-rich materials such as chalk or gypsum before the application of any overpainting. Also, macro XRF analysis revealed numerous elements that pertain exclusively to the original painting, like lead, mercury, and gold. The highest intensity of lead elemental peaks were dedicated in the areas of highlights, indicated its extensive use in the original painting. Mercury, associated with vermilion, was dedicated in the impressive highlights of Christ's stomach, as well as for the lettering on the background. Gold was present in the halo and some other decorative elements, suggesting that they were originally gilded. These three elements are of particular importance as they appear to pertain almost exclusively to the original painting. Therefore, by combining the corresponding elemental distribution maps, one may get a good idea about how the preserved original painting would look like. However, a detailed documentation of the areas that preserve original painting can be achieved only through the combination of the collected data. At this point, the process was done manually through the employment of image processing software, and we included data from IR reflectography, the X-ray radiography, and the elemental distribution maps of lead, gold, and mercury. The outcome suggests that the original painting is preserved in a considerable extent and shows stylistic features that allow for its dating to at least the early 18th century. Finally, we shall make a short comment about the complementarity of the employment techniques. A characteristic example that highlights the need to use multiple techniques is the area of the gospel. X-ray radiography reveals a book outline that deviates substantially from that observed macroscopically. The original text, written in a far more elaborate manner than the modern one, is visible only in IR reflectography, probably because it was rendered in carbon black. Finally, the initial letter of the text, an epsilon, is documented only through macro XRF because it contains mercury, which indicates the use of vermilion. In conclusion, the study of this post-Byzantine icon by using non-invasive imaging techniques such as UV fluorescence, X-ray radiography, infrared reflectography, and macro XRF has provided an invaluable look beneath its surface. These methods allowed us to uncover details of the original painting and better understand the artistry involved, as well as the materials used. The detection of elements like lead and mercury suggests the employment of particular pigments in the original painting, like white lead and vermilion. Additionally, elaborate decorative elements relieved by macro XRF and X-ray radiography highlight the artistic importance of the original painting that lays beneath the overpainting. Ultimately, this study allows for the detailed documentation of state extent of preservation of the original painting, and this piece of information will facilitate considerably the planning of future conservation interventions. Thank you for your attention.
Thank you for a very comprehensive presentation. It was a very nice example of what the combination of the rightly suitable techniques can offer to us. So do we have any questions? Yes, please.
Congratulations from me, Ioannis Lyrigis, to you and to your co-authors, the research team, for this excellent application work using a variation of non-destructive laboratory devices and to produce such useful results for the conservation purposes and also artistic styles. However, I would like to bring to your attention and to the audience here that a lot of work recently have been advanced, of avoiding the use of expensive devices which are not easily obtained in a laboratory, and to use alternative techniques to identify overpainting layers. This has been done, at least from my group, some years ago, by making image analysis of the icons by machine learning, deep learning, and also applying complexity measures and fractals. This is another approach which I think one of your authors knows, Alexopoulou, and we have discussed several times how to advance this. This is just a comment that it's not a critique, as you understand. Congratulations again, for the fine presentation and to the point, without any extra, information which, due to the limited time, we don't have, time to follow. So what you have done is an excellent work, but it's worthwhile also to say the advanced level, which is purely a research and not application of using, alternative techniques which produce accuracy, low cost, nothing, I could say, and also not needing availability of instrumentation. Thank you once more.
Thank you.
Thank you very much. Any more questions? Yes, please.
Only a curiosity. I would like to know if the term vermilion was used on purpose or as a synonymous of Cinnabar.
I can't hear, sorry.
I just wanted to know if the term vermilion has been used on purpose or as a synonymous of Cinnabar. So it's artificial or natural?
Sure.
Maybe for the chronology is vermilion?
Yes.
Okay.
We assume it's almost certainly artificial vermilion. It's an 18th century painting. We don't have, at least as far as we know, natural vermilion is not very much used. Artificial has dominated the market, according to the records and also the existing analysis. Although it is not very easy to discriminate between artificial, as you know better. But we assume that it is artificial. Yeah, thank you for the comment.
Any more questions? Okay, then we may thank again Ms. Nicolaidou.
Thanks, sir.
And move to the next presentation, an archaeometric study of small pigments in cultural heritage, production, characterizations, and uses by Kuga, Miguel, Larson, Boturas Cadina, and Fiallo Conde.
Good morning, everyone. Can you hear me? Okay, can you see my screen? Can you hear me?
Yes, we
Yes, we
can
can.
see your screen.
You cannot see my screen?
Yeah.
We can,
Okay.
yes, we can.
Okay, so good morning, everyone. I'm Eugenia. Today I'm going to present to you my master's thesis called An Archaeometric Study of Small Pigments in Cultural Heritage, Production, Characterization, and Uses. It's a master thesis that is happening during my master's in archaeological material science in the Erasmus Mundus joint master degree, which is a joint degree from University of Évora in Portugal, in Aristotle University of Thessaloniki, and Sapienza University of Rome. So let me start first by showing you the object that I'm working on. It's this beautiful manuscript that it has a very weird story because during cleaning project in the public library of Évora, everything was moved, all the manuscripts, all the archives were moved to the National Library of Lisbon. And during a random day, this manuscript appeared in the shelves. So this gathered a lot of attention because no one knew how it actually reached the shelves, where it went before it appeared. It didn't have any previous records, so the people from public library called art historians, scientists, in order to try and identify this manuscript. Another characteristic is that it doesn't have any signature or any sign who created it or to who was created for. Generally, it doesn't have anything. So after a first examination, it was estimated that it dates back to the 16th century, which was a very important century for Évora because it was the time that King John III transferred the Portuguese court in Évora. And along with him, a very important illuminator went called Antonio de Holanda, which has a very famous collection during the 16th century. And generally, this period in Évora was marked by significant artistic activity. So another very peculiar characteristic of the manuscript is that in some of the illuminations, a smalt pigment was identified. The use of smalt generally, it's very rare in manuscripts. It's used mostly in paintings or in ceramics and basically in enamels. But in manuscript, we could only find some examples from Italy, from Poland, and some from Persia, but very limited. So after some first look at the manuscript, we decided to start by analyzing this beautiful illumination because it really resembles the previous art from Antonio de Holanda. And after doing UV visible spectroscopy, the electronic transitions did not suggest the presence of some traditional pigment like ultramarine or azurite that they were very common in illuminated manuscripts. So we thought maybe there is a possibility that it's a cobalt-based pigment. Now, Cobalt in smalt is found in the tetrahedral geometry with oxygen, as you see in the picture. So this gives the characteristic absorbance band in the visible range at around 500 to 700 nanometers. Except from that, this absorbance band is further divided in 3 subbands, with minima at approximately 540, 590, and 640 nanometers, which is attributed to the DD electronic transitions of this tetrahedral geometry. So our first clue was there. Secondly, we tried doing portable XRF. This further confirmed the indication that the blue is cobalt-based pigment, since we found cobalt, and the extra hint with this method was that we were actually able to identify silicon in combination with potassium, which verified the presence of glass-based pigment. So we had very fast, we were sure that it was smalt. Let me tell you now some information about how smalt is created. Generally, it's a deep blue pigment, which is made by grinded potassium-rich glass and infused with cobalt oxide. The production involves calcining the cobalt ore, or zafir, as it is mentioned in the literature, and then it is mixed with a potassium-rich source, like wine tartar or potash, and the glass matrix. The glass matrix is generally quartz, but after the mid-15th century, they were trying to use a new kind of glass based on soda. And sometimes they were using a mix of these two. So the mixture was then melted at high temperatures to form the blue glass. And after after cooling, the glass was ground into a fine powder. Now, depending on the cobalt ore, scientists were able to distinguish different regions. Before the 12th century, the basic source of cobalt ore was the Eastern Mediterranean, while after the 12th century, it was moved in the modern-day region of Germany, with different impurities corresponding to different centuries. And after the 16th century, the mining of cobalt was focused only on cobalt ore production, and not like silver or bismuth that was before that. After that, we decided to take a very small sample from the manuscript with the permission of the public library, because manuscripts generally are very sensitive and it's not suggested to take samples, but because in this case we had a glass-based pigment and it's very new, we needed to see how this glass was made and to try and give a possible chronology to the manuscript. So the results from SEMI-DS showed cobalt in high amounts, and along with it, arsenic, nickel, and iron, which indicates a cobalt ore that comes from Snæberg 2 region, and specifically the smaltite. And this corresponds to the 16th to 18th century based on the previous table. Along with it, we found some lead that it's not related with the glass matrix, so probably the artist mixed some lead white along with the blue. Now, after the historical framework and the smalt pigment identification, we decided that it's very important to make some historical reproductions of this pigment. For us, that was a very important step because usually when the reproductions are made, they use ready-made pigments. But in this case, trying and creating the pigment from the beginning was very crucial for me to understand how difficult it was for the artist to prepare this pigment and why is it so rare in illuminated manuscripts. And from different recipes, we can possibly give a date to the manuscript more or less. So after an extensive literature review, I was able to find recipes that correspond to the results from SEM. And the first recipe was published on the 19th century, but it was originated from the 14th century, and the second one from the 16th century. All the reconstructions were made at the Carter Research Unit in University of Nova in Lisbon. And the two recipes differentiate on the amount of silica to tartar. The cobalt oxide generally was, depending on how dark you want the color, that much amount you need to put to your glass. So the first step was to make the glass frit preparation. We mixed silicon oxide with tartar in different proportions corresponding to the recipes. And we put the samples in a kiln. We started from an increasing temperature of 1,100 degrees. And then, depending on how the glass reacted, we increased at the maximum 1,250 degrees. So these were the temperatures that could actually reach because generally in the past they didn't have that high temperatures. So in total, the first sample was for 6 hours in the kiln, while the second one was for 5 hours. This was expected more or less because the second glass had more amount of tartar, which was used as a flux. So it was easier for the glass to melt.
Excuse me, 5 more minutes.
Yes. Okay, so after that, we tried doing quenching, but it was not successful since the glass melted. So after that, we tried to cool down the glass by letting it in a pot of water. But the first recipe was also not successful since it was not melting properly. So we tried doing it again. This time we repeated the first recipe and we tried doing another recipe from the 16th century and the same procedure in the kiln. And the only difference was that we chose to calcine the tartar first in order to fuse better in the glass. So the results are, as you see here, successful. We had our glass. And then we prepared the smalt glass by infusing cobalt oxide in 3% in each sample. The same procedure in the kiln, and then the crucibles, we decided to just put them in a pot of water in order to cool down. In that step, we decided to make a new recipe, the same as the first one, but to put all the ingredients together and see how it will react. And it actually worked, but it needed more time in the kiln. So this is the result. This is a very fine and beautiful blue smalt pigment. And now, after we did the historical review, we managed to make the smalt pigment. And now you can see the results from digital microscope. Some of the parts are not very well fused, but this is for a future work that I think you will be able to read on December onward. So thank you so much for your time, and I want to thank the Roadmap project that supported this work and the ArcMat Erasmus Mundus program. Thank you.
Thank you for keeping up with time. It was a very information-rich presentation. And do we have any questions? Questions? I have one. In your reproduction, well, first, I'm impressed by the way that how you looked on your material, and you were very keen in reproducing pigments. And I know the people, I mean, the researchers in Portugal are very well known about that. You have a good tradition on that. I mean, concerning your reproduction of smalt, were you able to see the same transitions in your UV reflection spectrum that you mentioned in the real, you mentioned that in your real sample?
I haven't reached so far at this point. Actually, we'll do that next week because I haven't produced the pigment yet. I only produced the glass. So now I have to just prepare the pigment by using different binders like gamma arabic and egg white. And then after I produce the pigment, I will do the same analysis like force, XRF and everything. And based on that, I will see if the recipes that I chose are actually corresponding to the one that the artist used or something similar. And from that, we can date the manuscript.
Thank you very much. So since we don't have any more questions, thank you again.
Thank you.
And we're going to move to the last presentation in this session. It is titled Infrared Photography for Documentation and Analysis of Body Painting and Tattooing on Pre-Hispanic Mummified Human Remains by Dr. Bach. Do we have connection? Okay, I'm instructed that this presenter may have problems with connecting, so we could just show the presentation for some time to run it through for the audience. So we still have a basic idea of what is about. Good. Oh. Is it possible that we zoom in somehow? Maybe to some parts of the page? Yeah. Okay. Can we roll it up a bit, please? Yes. Good. So can we move it a bit up again for the conclusions? Okay, is this all we have? This page, okay. So I think I ran through all of it myself at least, so I don't know if you. Okay, so despite the difficulties for the connection, let's thank the presenter. And now I think that was the final presentation of this session. And let's move down for some coffee break and resume back with the next session. Thank you.
Να ξεκινήσουμε. Ποιος είναι υπεύθυνος εδώ? Να ξεκινήσουμε. Οκ, ευχαριστώ. Καλημέρα, καλησπέρα. I would prefer to speak in Greek this time, although the presentations would be in English, I suppose, either in the oral presentation or in the PPT. There are reasons I'm doing that. Είναι πολύ βαρύ για μένα ακόμη και δεν ξέρω πόσο θα κρατήσει αυτό το βάρος που αισθάνομαι να είμαι εδώ χωρίς τον Νίκο. Θα κάνω μια προσπάθεια να διατηρήσω ψυχραιμία, να σας καλωσορίσω, έστω εσάς τους λίγους. Όλοι έχουμε δουλειές, καταλαβαίνω. Επιστρέψαν στον τόπο τους. Εκτιμώ την παρουσία σήμερα στην πρώτη τελευταία session και ιδιαιτέρως εκτιμώ την παρουσία της αγαπητής κυρίας Ζημή, η οποία είναι και σήμερα από το Πανεπιστήμιο Παλαιογονής, από το Τμήμα Ιστορίας και Αρχαιολογίας και Διαχείρισης Υλικών, η διευθύνουσα μετά την απώλεια του Νίκου, το Εργαστήριο Αρχαιομετρίας. Το εκτιμώ ιδιαίτερα και βαθύτερα. Σε ευχαριστώ, Νίκο. Νομίζω ξεκινάω, έχω το privilege να ξεκινήσω πρώτος, όπως με έχει το πρόγραμμα. Οπότε θα πρέπει να σηκωθώ και να δει το πρώτο slide, παρακαλώ. Θα σας μιλήσω για μία προσπάθεια να επισκεφθώ εγώ και η ομάδα μου ξανά την γνωστή μέθοδο χρονολόγησης οψιανών, obsidian hydration dating, την παραδοσιακή. Αυτή δηλαδή που εισήχθηκε με κατά εμπειρικό τρόπο, αλλά αρκετά ικανοποιητικό, το 1960 από τους Friedman and Smith. Είναι μια λοιπόν παρουσίαση που αφορά ένα εξειδικευμένο πεδίο βελτίωσης της υπάρχουσας μεθόδου χρονολόγησης ενυδάτωσης οψιανών. Τα δεδομένα που χρησιμοποιούμε είναι από τη βιβλιογραφία, αλλά και κάποια νέα, αλλά με ένα άλλο τρόπο προσέγγισης και διαχείρισης. Η ομιλία μου αναφέρεται στους οψιανούς, όλοι γνωρίζουμε, αλλά καλό είναι να υπάρχει μια εικόνα περίπου πώς είναι οι οψιανοί. Οι οψιανοί εννοώ που κατεργάζονται και γίνονται εργαλεία. Τι σημαίνει ότι έχουμε διάχυση του νερού στον οψιανό, οι μέθοδοι που υπάρχουν και πώς, σε ποιο σημείο εντοπίζεται η νέα προσέγγιση που προτείνουμε, ποιες είναι οι δυσκολίες στη μέθοδο, την παραδοσιακή μέθοδο του οψιανού και η νέα calibration που παρουσιάζουμε στην σημερινή μας εργασία, μία δηλαδή εξίσωση ένα βήμα πιο πέρα από ό,τι υπήρχε, το standardization, η βαθμονόμηση, θα έλεγα, μία καμπύλη βαθμονόμησης για τις ηλικίες από την παραδοσιακή μέθοδο που σας είπα, με την εμπειρική μέθοδο του Friedman and Smith του 1960. Δηλαδή μιλάμε τώρα για 40-65 χρόνια πριν. Είναι γνωστό, φαντάζομαι σε όλους σας, η σύνθεση του φυσικού γυαλιού που λέγεται οψιανός και ότι από τη στιγμή που γίνεται εργαλείο, η υγρασία του περιβάλλοντος, υδρογόνο 2 οξυγόνο, το νερό δηλαδή, διεισδύει στην επιφάνεια του εργαλείου σε όλες τις κατευθύνσεις, αλλά με προεξάρχουσα κατεύθυνση κατά βάθος στο εσωτερικό του οψιανού και ακολουθεί μία καμπύλη η οποία είναι σαν ένα S και το βάθος που μπαίνει το νερό στον οψιανό, το βάθος σε μικρόμετρα είναι συνάρτηση ηλικίας. Το βάθος το μετράμε με μικροσκόπια, αλλά και με μέθοδος ιοντικές δέσμες από την μέθοδο δευτερογενής φασμοσκοπική μέθοδος με τον βομβαρδισμό ιόντων. Η μέθοδη λοιπόν είναι η πρώτη που σας είπα, η εμπειρική, που είναι από το Friedrich Smith του 1960. Ο τύπος της εξίσωσης είναι αυτός που βλέπετε, χ τετράγωνο ίσον κ επί ταφ. Το ταφ είναι ο χρόνος, το κ είναι σταθερά διάχυση, στα χ που μπαίνει το νερό μέσα στο οψιανό, που εξαρτάται από πολλούς παράγοντες, και το χ, το οποίο είναι το βάθος σε μικρόμετρα που το νερό έχει διεισδύσει τον οψιανό. Τρία πράγματα έχουμε εδώ πέρα. Αν ξέρουμε το χ και το κ βρίσκουμε το ταφ, το χρόνο δηλαδή. Είναι μια άλλη μέθοδος που, μάλλον όχι η ίδια μέθοδος, αλλά με κάπως προχωρημένο το εντοπισμό του στρώματος χ, με υπέρυθρη ακτινοβολία, IRPS, φωτοακούστικη σπεκτρόσκοπη. Μια άλλη που χρησιμοποιείται η μέθοδος SIMS, Secondary Ion Mass Spectrometry, και βρίσκουμε το βάθος του νερού υπό τη μορφή καμπύλης, η μορφή μάλλον μεταβολής της συγκέντρωσης του νερού, συναρτήσεως του βάθους μέσα στον οψιανό. Και η δικιά μας μέθοδο που αναπτύχθηκε αρχάς του 2000 στη Ρόδο, που είναι η SIMS-SS, που έχουμε εντοπίσει ένα στρώμα κορεσμού όταν το νερό μπαίνει στον οψιανό. Μετά από σύντομο χρονικό διάστημα φτάνει σε ένα σημείο κορεσμού που δεν μεγαλώνει η συγκέντρωση του νερού, απλώς τα μόρια που έρχονται από πίσω από την επιφάνειά του προς τα μέσα το σπρώχνουν προς το βάθος. Αυτή η αρχή τη χρησιμοποιήσαμε και έχουμε, βασιζόμενοι σε ένα νόμο του ΦΙΚ, που έχει να κάνει με τη διάχυση και την κινητική των μορίων του νερού σε ένα μέσον, εδώ το μέσον είναι το γυαλί, και έχουμε μία, θα την έλεγα, φαινομενολογική approach. Έχουμε εμπειρική, φαινομενολογική και επιστημονική μέθοδο, που όλα εξηγούνται επιστημονικά. Αυτή είναι η φαινομενολογική, δηλαδή εν μέρει κατά 80% μπορεί να είναι επιστημονική, είναι, αλλά έχουμε και ένα 20% που το έχουμε εμπειρικά. Λοιπόν, αυτό που εμείς επικεντρωνόμαστε, ξαναρχόμαστε, όπως σας είπα στην αρχή, στη γνωστή μέθοδο του 1960, να την διερευνήσουμε περαιτέρω, αλλά με μια νέα ματιά. Το diffusion rate, το D, διάχυση, ο ρυθμός διάχυσης, πρέπει να προσδιοριστεί με ακρίβεια, γιατί εξαρτάται και από τη θερμοκρασία του περιβάλλοντος και όχι μόνο. Περιβάλλοντος ταφής του εργαλείου στο burial site. Έχουμε δει ότι βλέπετε την εξίσωση χ τετράγωνο ίσον κ επί ταφ είναι στο τετράγωνο το χ, αλλά κάποιοι ερευνητές έχουν βρει και 0,5, 1,5, κάπου αρχίζει λίγο να γίνεται μια αβεβαιότητα εδώ. Έχουν διαπιστώσει ότι η θερμοκρασία, μικρές αποκλίσεις από την μέτρηση της μέσης θερμοκρασίας από τη στιγμή που έχουμε ταφή του υλικού μέχρι σήμερα, αν έχουμε μικρές διαφορές, αυτό έχει μια μεγάλο αποτέλεσμα στην ηλικία, αλλά αυτό θα μπορώ να πω ότι αν μου επιτραπεί εντός εισαγωγικών η έκφραση, εκρύπτεται από τους ερευνητές, δεν το πολύ έλεγαν δηλαδή. Αυτό μου θυμίζει λίγο και το calibration που γίνεται στο ραδιάνθρακα, που παρουσιάζουν μια πολύ μικρή λάθος στις μετρήσεις, ενώ στην ουσία όταν χρησιμοποιείς το calibration curve δεν είναι τόσο μικρό το λάθος, είναι πολύ μεγαλύτερο. Τελικά το diffusion rate που είναι το K στην εξίσωση επάνω εξαρτάται από, σας είπα, πολλούς παράγοντες. Metrics, diffusion species, internal water, modifiers of obsidian, H2O, το νερό που υπήρχε στο οψιανό πριν γίνει εργαλείο. Όταν γίνεται οψιανός υπάρχει ένα μικρό ποσό νερού που έχει μείνει κρυσταλλικό εκεί. Και είναι από το 0,1 μέχρι το 1% περίπου. Και γενικά μέχρι τώρα έχουμε μια δυναμία η επιστημονική κοινότητα να περιγράψει με ακρίβεια το τι συμβαίνει στο diffusion, στο διάχυση του νερού μέσα στον ωκεανό, αν και έχει προσεγγιστεί, όπως είπαμε, με τον νόμο του Φικ. Εν τούτης υπάρχουν ακόμα πεδίο ανοιχτό για να εξηγήσουμε τις κινητικές αυτών των μορίων του νερού και των ιόντων, γιατί το υδρογόνο 2 οξυγόνο από ένα σημείο και πέρα γίνεται OH, με τις αντιδράσεις που γίνονται με το πυρίτιο και μέσα στο σώμα του οξεανού. Και επίσης βρήκαμε και κάτι το δυσανάλογο όταν μετράμε με το SYMS, αυτή τη μέθοδο ακριβώς το βάθος του οξεανού, σε σχέση με το ίδιο δείγμα το μετρήσουμε μικροσκοπικά, υπάρχουν διαφορές. Οπότε πρέπει να είναι κανείς προσεκτικός όταν χρησιμοποιεί μικροσκοπικές thin section εικόνες, να είναι κατά αναλογία να βαθμολογηθούν και με τη μέθοδο του SYMS. Άρα λοιπόν έχουμε κάποια προβληματικούς προσδιορισμούς στην προσδιορισμό του RIM. RIM είναι το στρώμα ενυδάτωσης που, επαναλαμβάνω, είναι στο βαθμό του μικρόμετρα, micrometers. Περίπου, να σας καταλάβετε, για όσους δεν είναι familiar, 1000 χρόνια ένα εργαλείο να μείνει σε ένα sediment, μπορεί να έχουμε ένα μικρόμετρο βάθος του νερού. Όταν μιλάμε για 4.000 χρόνια, να φανταστείτε γύρω στα 4 με 5 μικρόμετρα. Μιλάμε σε αυτή την κλίμακα. Μικρόμετρα κάτω του 10. Εκτός αν είναι κάνα 70-80.000 χρόνια που μπορούν να είναι εκεί στο 8 και στο 10. Αυτό είναι το maximum. Λοιπόν, η κλασική μέθοδος είναι αυτή. Χ τετράγωνο στο K επί τάφ. Προσδιορίζουμε λοιπόν το K και το Χ και βρίσκουμε το τάφ. Αυτή είναι η ηλικία. Εμείς πήραμε δεδομένα από διάφορα μέρη του κόσμου, οψιανών, τα οποία έχουν θερμανθεί σε θερμοκρασίες υψηλές, από 120, 130, 180 βαθμούς Κελσίου, ως επίσης και θερμοκρασίες πειραματικές στο εργαστήριο εννοώ, μεταξύ 10, 20, 30 και 40 βαθμούς Κελσίου, που είναι οι θερμοκρασίες του περιβάλλοντος. Αυτές λοιπόν που υφίσταται το ένα εργαλείο, οπουδήποτε να είναι στον κόσμο, δεν μιλάμε τώρα για ακραίες περιπτώσεις, ας πούμε, έτσι, αρκτική περιοχή κτλ. Μιλάμε στο χώρους που έχουμε ανάπτυξη πολιτισμών. Μέχρι τώρα όλες οι υλικές που έχουν παραχθεί από τους ερευνητές βασιζόμενοι σε αυτή την μέθοδο τη Χ τετράγωνο στο K επί τάφ, γίνεται σύγκριση πάντα με άνθρακα 14. Δηλαδή δεν είναι ανασφαλής οι επιστήμονες και λένε να πάρουμε και μια άνθρακα 14. Τι σημαίνει αυτό? Στο στρώμα που βρέθηκε ο οψιανός, αν υπάρχει κάποιο καρβουνάκι, αν υπάρχει κάποιο οργανικό, να το κάνουμε και αυτό, αφού είναι στο ίδιο στρώμα, στο ίδιο ορίζοντα, θα είναι η ίδια ηλικία, να δούμε πώς είναι η δική μας ηλικία με το obsidian hydration dating. Και κάποιες φορές χρησιμοποιείται και η φωτάβια, αλλά η φωτάβια μην ξεχνάμε ότι έστω και 5% λάθος έχει ένα λάθος, αλλά και πάλι μπορεί να χρησιμοποιηθεί για σύγκριση με την παραδοσιακή μέθοδο. Εδώ στο πάνω μέρος βλέπετε οι μέθοδοι, οι καμπύλες που παίρνουμε όταν χρησιμοποιούμε SIMS, Secondary Ion Mass Spectrometry, για να βρούμε αυτό γράφει εδώ πέρα, δεν ξέρω αν είναι. Από εδώ έως εκεί είναι το βάθος. Όταν είναι η θερμοκρασία που έχει μείνει για 10 χρόνια, ας πούμε, το οψιανός, το βάθος του νερού που μπαίνει μέσα είναι από την αρχή που είναι η επιφάνεια μέχρι εδώ. Εάν το κρατήσουμε ίδιο χρόνο, 20 χρόνια, πάμε σχάρι, αλλά 40 βαθμούς Κελσίου, πειραματικά στο εργαστήριό μας, τότε θα πάει η καμπύλη είναι αυτή εδώ πέρα. Βαδίζει πιο βαθιά. Άρα λοιπόν το μήκος του νερού που έχει διεισδύσει είναι από εδώ έως εκεί. Βλέπετε λοιπόν πως για διάφορες θερμοκρασίες το βάθος που μπαίνει το νερό διαφέρει. Αυτό είναι με τη μέθοδο SIMS. Ενώ εδώ μετράμε αυτό το βάθος, αλλά μικροσκοπικά. Εδώ είναι η επιφάνεια του οψιανός και εδώ είναι το μέτωπο του νερού. Και έτσι μετράμε πόσα μικρόμετρα είναι εδώ πέρα. Αυτή είναι οι δύο μέθοδοι προσδιορισμού του ενυδατωμένου στρώματος. Έχουμε αναπτύξει ένα πρωτόκολλο, ακριβώς για να μπορεί ο κάθε ερευνητής να επαναλάβει αυτά που έχουμε πει και κάνοντας κυρίως χρήση της κινητικής των αερίων αλλά και άλλων μέσων προς το στερεό του Arrhenius equation. Αυτές οι εξισώσεις που χρησιμοποιήσαμε είναι η βασική αυτή εμπειρική του Arrhenius, η επεξεργασία του Arrhenius και κυρίως το plotting που είναι το λογάριθμος του κάπα, που είναι το κάπα, ο ρυθμός διάχυσης, στην εξίσωση, αν θυμάστε, συναρτήσει το ένα προς τάφο που τα άφηνε σε θερμοκρασία σε Kelvin και φυσικά ακολουθώντας μια μαθηματική γνωστή προσέγγιση, προσδιορίζουμε κλίσεις και τα λοιπά, ούτως ώστε να βρούμε την activation energy, την ενέργεια δηλαδή που αντιστοιχεί στο συγκεκριμένο ψιανό και στην σύνδεση των μορίων του νερού. Εδώ δίνουμε μερικές εικόνες από την επεξεργασία των δεδομένων αυτών. Εδώ, παραδείγματος χάρη, όταν λέμε B1, B2 κτλ., είναι από πού προέρχονται τα δείγματα. Αυτό είναι από την Καλιφόρνια, το BH, 2 πηγές, Μεξικό, Νέα Ζηλανδία, Περού, και εδώ το Uml και το WEC, Umlean και WEC, είναι από τη Νέα Γουινέα. Βλέπετε, καλύπτουμε ένα μεγάλο φάσμα παγκοσμίως για να δούμε τη συμπεριφορά των διαφόρων αψιανών από τόσοι που γεννήθηκαν, που παρήχθηκαν δηλαδή από το ηφαίστειο, πώς δημιουργήθηκαν, ποια ήταν το structure, η δομή τους και πώς συμπεριφέρονται σε αυτά τα φαινόμενα. Εδώ είναι παρόμοια εικόνα, βλέπετε μια γραμμική, πολύ καλή γραμμική σχέση των χαμηλών θερμοκρασιών περιβάλλοντος και των υψηλών θερμοκρασιών στο εργαστήριο. Είναι πάρα πολύ σπουδαία. Εμείς χρησιμοποιούμε θερμοκρασίες, όταν πάμε να χρονολογήσουμε, κάπου εδώ γύρω. 30, 20, 15, 8 βαθμοί Κελσίου. Έτσι. Αλλά πρέπει, για να υπολογίσουμε αυτές, και να υπολογίσουμε κάποιες στοιχεία που έχουν να κάνουν με την παράμετρο της σταθεράς διάχυσης, δημιουργούμε αυτά τα plots. Αυτό που διαπιστώσαμε είναι ότι η παρουσία του νερού του πρωταρχικού που υπήρχε στο ψιανό όταν έγινε ο ψιανός. Όχι όταν έγινε εργαλείο και άρχισε να μπαίνει το νερό του εξωτερικό, αυτό που υπήρχε από τότε που έγινε ο ψιανός. Είναι, σας είπα, 0,05 μέχρι το πολύ, 1%. Εκεί κυμαίνεται. Με μέσο όρο 0,2-0,3% το νερό αυτό. Είδαμε ότι αυτό το νερό παίζει ρόλο στη χρονολόγηση που προσπαθούμε να κάνουμε. Αν ελάβουμε υπόψη μας την παρουσία του νερού και την ποσότητα στο κάθε ψιανό που χρονολογούμε, πέφτουμε έξω. Λάθος. Γι' αυτό και υπήρχε και μια έλλειψη εμπιστοσύνης από τους αρχαιολόγους από πολλά χρόνια στις ηλικίες που έδαιναν οι επιστήμονες που ασχολούνταν με το obsidian hydration dating. Αυτός ήταν ένας από τους κύριους λόγους. Αλλά υπάρχουν και κάποιοι άλλοι που όλοι μαζί δίνουν μια αβεβαιότητα. Και σε κάποιες περιπτώσεις, αν έτυχε να είναι σωστή η ηλικία, αυτό είναι by chance. Και αυτό φυσικά δεν είναι επιστημονικό. Και εδώ βλέπετε μια καλή γραμμική σχέση για οψιανούς, αυτούς τους οψιανούς εδώ πέρα, από αυτές τις πηγές, οι οποίοι έχουν νερό 0,3%. Όλα δηλαδή οι πηγές αυτές έχουν ίδιο ποσό νερού. Αν είχαν 0,3, θα κάναμε άλλη καμπύλη. Όχι την ίδια. Αυτό δεν ξανά έχει γίνει πριν. Η νέα μας λοιπόν εξίσωση, που είναι ένα βήμα πέρα από αυτή που υπήρχε, με τις νέες σκεπτικό που σας έχω εξηγήσει, έχει να κάνει function of κάπα, το κάπα πρέπει να το προσδιορίσουμε, σταθερά διάχυση, τη θερμοκρασία burial temperature και το ποσό του νερού παρών. Οπότε γνωρίζοντας τη θερμοκρασία με τρόπους που υπάρχουν. Έχουν κάνει κάποιοι τρόποι, όχι στα 100 χρόνια μόνο, αλλά και από κλιματολογικά δεδομένα μπορούν να βρουν κάποια μέση τιμή θερμοκρασία συν-πλήν. Συν την ποσότητα του νερού, υπολογίζουμε το κάπα από τα plots που σας έδειξα και από την εξίσωση χ τετράγωνο ίσον κάπα επί ταφ, προσδιορίζουμε το χρόνο. Αυτό είναι το όλο. Αυτές είναι οι δύο εξισώσεις που έχουμε προσδιορίσει για πρώτη φορά. Αυτή αναφέρεται σε χαμηλό νερό και αυτή αναφέρεται σε υψηλό νερό. Υψηλότερο ποσότητα νερού μιλάμε 0,2%. Εδώ μιλάμε 0,11%. Και σε τι διαφέρει, αν παρατηρήσετε κάπως πιο κλειστά, διαφέρει σαν τον παράγοντα εδώ. Το άλλο είναι ίδια. Η διαφορά του νερού. Εδώ σας δίνω μερικά χαρακτηριστικά που αφορούν από την εξίσωση των αρένιων στα plots που χρησιμοποίησαμε, που έχουν να κάνουν με την κλίση, με το λογάριθμο ενός συντελεστή pre-exponential στην εξίσωση του αρένιους και το ποσό του νερού από διάφορες πηγές και συνδυασμούς πηγών. Δηλαδή να είναι το Καλιφόρνια μαζί με το Ούμλιαγκ, που το Ούμλιαγκ είναι Νέα Γουινέα. Περού μαζί με άλλη μια θέση στο Παπούα. κτλ. Οπότε βλέποντας διαφορές. Τι βλέπουμε εδώ στο κίτρινο? Αυτό το κίτρινο σημαίνει για νερό 0,10 και για νερό 0,21. 0,25, ψηλότερο. Παρατηρείτε κάτι? Φυσικά, αν δείτε τα slopes και τα LNA, όταν είναι μικρό το νερό, είναι διαφορετικό από όταν είναι μεγάλο το νερό. Δηλαδή, πλέον είναι is a fact, ότι όταν έχουμε διαφορετικό νερό, πρέπει να αντιμετωπίσουμε τη χρονολόγηση ενός οψιανού, αφού προσδιορίσουμε το νερό με IR, είναι εύκολο, δεν είναι δύσκολο, και μετά να το βάλουμε στην εξίσωση που έχουμε προτείνει. Εδώ χρησιμοποίησαμε αυτά τα αποτελέσματα από περιέργεια, καταρχήν, παίρνοντας διάφορες θέσεις, χρονολογημένες δηλαδή θέσεις, από και άνθρακα 14, κυρίως όμως από ψιανό, το είχαν κάνει άλλοι ερευνητές, και κάποιες φορές υπήρχαν και άνθρακα 14. Αυτές οι πηγές προέρχονται από το Easter Island, νησιά του Πάσχα, Νάπα Βάλι που είναι στην Αμερική, η Ιαπωνία, Παπούα και Σερατάκι που είναι στην Ιαπωνία. Αυτό τα χρώματα, βλέπετε τις μεθόδους που χρησιμοποιήσαμε. Η δικιά μας είναι στο low εδώ πέρα, στο πράσινο, και στο μαύρο. Έχουμε βρει και κάποια άλλη εναλλακτική εξίσωση που την ονομάζουμε H13OEPL33. Το πορτοκαλί είναι αυτές οι ηλικίες που δίνει η βιογραφία και συγκεκριμένα ο συνάδελφός μας, ο Chris Stevenson, που είναι και συνεργάτης μας. Το κόκκινο λοιπόν είναι η σύγκριση που γίνεται με τον author, οπωσδήποτε τον author, και οι άλλες είναι οι μέθοδοι που χρησιμοποιήσαμε διάφορες. Βλέπετε λοιπόν, αν πάρουμε το κόκκινο, που είναι αυτή που δίνει ο συγγραφέας, η δικιά μας μέθοδο είναι στο πράσινο και στο μαύρο. Πράσινο και μαύρο. Οπότε μπορείτε να δείτε περίπου πού βρισκόμαστε σε σύγκριση με αυτά που αναφέρει ο συγγραφέας. Να κάνει μια όμως παρένθεση εδώ πέρα, ότι οι συγγραφείς δεν είχαν λάβει υπόψη οι προηγούμενοι. Έτσι. Όλα αυτά που σας είπα με τα νερά και τα λοιπά. Οπότε υπάρχει ένα ερωτηματικό αν οι ηλικίες τους ήταν σωστές. Αλλά είναι πολύ encouraging, πάρα πολύ ενδιαφέρον και πολύ ενισχυτικό ότι παίρνουμε αυτές τις ηλικίες με την μέθοδο αυτή που έχουμε αναπτύξει. Εδώ είναι άλλη μια σειρά πολλών ηλικιών με oxide hydration dating που προέρχονται από την ίδια θέση, Ξαλτοκάν, είναι μια σειρά από κατά βάθος προφίλ, και εδώ είναι η μέθοδο με τα χρώματα, δίνουν τη μέθοδο του αρχικού του Stevenson, όπως το είχε δημοσιεύσει, με τη μέθοδο όμως την προηγούμενη, δηλαδή την κλασική μεν, αλλά χωρίς να λάβει υπόψη αυτές τις διαφοροποίησεις στο νερό που σας είπα. Και οι άλλα χρώματα είναι οι δικές μας οι προσεγγίσεις, και το κίτρινο είναι το πιο, ας πούμε, που λατρεύουμε, θα έλεγα, και θα δούμε να το συνεχίσουμε πιο πολύ. Βλέπετε μια πολύ καταπληκτική συμφωνία, εκτός από μία περίπτωση εδώ, νομίζω, μία εδώ και λίγο εδώ. Δηλαδή, όλα τα άλλα όμως είναι πάρα πολλές. Είναι 50-60. Όχι, είναι 81, τι λέω. Άρα είναι... Εδώ φαίνεται έχουμε μια πάρα πολύ καλή. Ίσως γιατί επειδή είναι η ίδια σειρά από τη ίδια θέση και ο ψιανός, ίσως να έχουμε, επειδή έχουν ίδιο νερό, ίδια πηγή ψιανού, γι' αυτό να πάρουμε καλά αποτελέσματα. Και αυτά τα δύο εδώ πέρα, τα κίτρινα και αυτό το δύο, ίσως να οφείλεται σε δύο λόγους. Είτε αυτά τα δύο δήματα να προέρχονται από άλλες πηγές στο ξαγλουτοκογάμι και όχι από την πηγή που προέρχονται όλα. Αυτό είναι το ένα, είτε κάποιο λάθος έχει γίνει στην προηγούμενη μέθοδο. Γιατί το λέμε στην προηγούμενη? Γιατί όλα τα άλλα ταιριάζουν. Δεν μπορεί λοιπόν στις δικές μας μέθοδο όλα να ταιριάζουν και εκτός από δύο. Άρα λοιπόν αυτό το συζητάμε και προσπαθούμε να το λύσουμε με τον συνεργάτη μας, να δούμε αυτά τα δύο, τι συμβαίνει σε αυτά τα δύο. Conclusion λοιπόν και τελειώνω. Κάτω από τις παρούσες συνθήκες, θεωρούμε το νερό παίζει μεγάλο ρόλο αυτό που υπήρχε μέσα όταν κάνουμε χρονολόγηση με την traditional method του Οψιανού του 1960, εκεί δουλεύουμε, και ότι επί του παρόντος θα μπορούσε να χρησιμοποιηθεί για προγράμματα χρονολόγησης Οψιανών. Είναι η ευαισθησία της θερμοκρασίας, την έχουμε επιβεβαιώσει, κανείς δεν μπορεί να το αμφισβητήσει. Σας είπα ότι ήταν hidden κάπως αυτό το σπουδαίο comment, ας πούμε, από τους ερευνητές που παρήγαγαν ηλικίες με obsidian hydration dating. Hidden, εντός εισαγωγικών το λέω αυτό. Έχουμε κάνει πάρα πολλά τεστ και έχουμε αποδείξει, να σας πω ένα παράδειγμα, στο Σιρατάκι, 18.000 χρόνια και με άνθρακα 14, αυτό είναι με σιγουριά λοιπόν, όταν οι θερμοκρασίες μεταβάλλονται μεταξύ 5 και 10 βαθμούς Κελσίου, λάθος δηλαδή, είναι 5, είναι 6, είναι 7, είναι 10, η ηλικία μεταβάλλεται μεταξύ 26 και 13.000 χρόνια πριν από σήμερα. Και ένας βαθμός λάθος αντιστοιχεί 15% αβεβαιότητα στην ηλικία. Άρα λοιπόν εδώ θέτουμε και limitations, περιορισμούς. Σε ένα άλλο παράδειγμα, στο νησιά του Πάσχα, 400 π.Χ. Πριν από σήμερα, για θερμοκρασίες 19 με 23, η εξίσωσή μας δίνει 406 με 230 πριν από σήμερα και για 21,5 συν 1 βαθμό λάθος η θερμοκρασία δίνει 262 με 336 πριν από σήμερα. Άρα λοιπόν, επί του παρόντος θα μπορούσαμε να πούμε μεταξύ 0,1-0,3% νερό μπορούν να χρησιμοποιηθούν αυτές οι εξισώσεις με αρκετά καλή ακρίβεια. Το μέλλον αυτής της εργασίας είναι να επεκτείνουμε το νερό από 0,3 σε 1%, να βρούμε οψιανούς με περισσότερο άλλη ποσότητα νερού και αυτή η εργασία είναι μία από ένα τρίο, από τρεις που τρέχουν ταυτόχρονα, που τελικά δίνουμε θεωρώ, ένα τέλος, μια βεβαιότητα, το πόσο μπορούμε να βασιστούμε στην παραδοσιακή μέθοδο του 1960, ποια είναι τα περιορισμοί, τα limitations και πραγματικά μέχρι ποιο σημείο μπορούν να γίνουν, έστω και με 15% λάθος, να γίνουν αποδεκτές οι ηλικίες από την αρχαιολογική και ανθρωπολογική κοινότητα. Αυτό λοιπόν είναι μία από τα τρεις εργασίες που κάνουμε και υπάρχουν και άλλες δύο που προσεγγίζουμε από άλλους τρόπους το ίδιο αποτέλεσμα, ακολουθώντας μια μαθηματική προσέγγιση που έχει να κάνει με το power law. Δηλαδή το diffusion rate μέσα στον οψιανό που ακολουθεί μια συγκεκριμένη μαθηματική συνάρτηση. Αυτό ήταν όλο. Ευχαριστώ πολύ που με ακούσατε. Ερωτήσεις?
Ευχαριστούμε πάρα πολύ. Πάρα πολύ ενδιαφέρον. Είχαμε και κάποιες συζητήσεις παλιότερα, Γιάννη, γι' αυτό και τώρα τα θυμήθηκα διάφορα πράγματα. Απλά, can I say the question in English, though? You mentioned the Arrhenius kinetics, and from that, of course, you can calculate activation energies. So, what is the exact meaning of the activation energy? Does it have with what is the energy barrier that water has to nest into the silicate network or something different?
Exactly, this is what you say, but we have found that this activation energy is related perfectly with water. That's why then we took this plot, further plot, energy versus water, and we use this plot in order to go to the next step in the calculation of the age. So, if I answer to you, it was necessary for is related to the water, and that was found by Doremus, not by us, but in crystalline, in glass, studies, papers not related to the obsidian hydration technique, but that was a principle. So we tried to use this to see if it fits to our data. It fits very well. So the water is a necessary and must, that we have to correlate with energy, and then using the equations that I have shown you, we take out the energy, it remains only the water, the K, and then we can edit up the temperature, and then the H is obtained by these three parameters. That is the use of activation energy. It's a byproduct. I mean, indirectly in order to go to the water.
Okay, thank you. Can I ask another quick question? Were you able to detect possible levels of hydration? For instance, for crystalline materials, water can be incorporated in several levels, like very deep in the structure, outer in the structure, or in the, just absorbed on several layers. But here with obsidian, which is not crystalline material, are you able to observe something similar?
I would not say layers. I would say variation of concentration of water as a function of depth. Variation, not layers. The S-like curve, which follows the fixed second law of diffusion, if so you remember, gives exactly what I want to say. Not layers. It's a variation of concentration, but there are, in this S-like curve, we have observed two parts which of the curve which reflect the kinetics and the chemical reactions that take place between the inward water and the structure. And we have seen that the fixed law is applied to a second part of the curve, where the curve drops down to the tail. In the first part, it seems to apply, a different law. So we have two different laws.
Right.
That's why this has confused, many people if they apply the Fick law to the whole equation. And indeed, crystalline materials there exist, there. We know that, but the water, when it says, the molecule, a small piece of, say, 10 microns or 20 microns of a quartz or a biotite, either overpasses or tries to penetrate, but the penetration will be very, very slower than with it. But does not alter the principle of diffusion fraud, no matter if there are various barriers, let's say. The rest of the part of obsidian provides a free space for the molecules to move inside, so we can identify the rim, the water fraud, as I have shown you in some micro photographs from thin sections.
Great, thank you very much. Shall I ask you a question? Thank you, Yanni. Okay. I have two questions. The first one, would be any tendency that the penetration depth might be dependent also on the absolute value of the concentration of the water on the surface? I mean, if there is more on the surface, then it is going deeper inside the volume of the obsidian?
Yes. No, it has not been observed something like that. It is like a sponge that takes water, it reaches a saturation, and then after no matter how much water you leave, it will not happen anything. Here, in this case, what happens is we reach a surface saturation, no matter how much water is outside. I mean, in the surface, no matter. It does not matter. So it matters only once they get into the obsidian. The chemistry and the kinetics is such that the law of diffusion is applied, and as I say, in the first very short period of time, could be hundreds of years, to be specific. it reaches this level and this higher level, this center saturation, which doesn't go any farther. The only thing is goes forward inside, taking, you know. So this is my.
Probably you have asked also already my second question, which was with respect to the effect of humidity, because you mentioned, let's say, the penetration versus temperature, and if there is this saturation that perhaps the humidity doesn't play so important role, but
Yes.
if the humidity on the other hand is very low.
Yeah, the effect of humidity has been studied, you know, by many papers, but they have not found significant. Only from many papers I have seen, you know, a couple of them they say, oh, they play some role, the humidity, but all the others they say no, it's very minimal. So I take, you know, the majority that say it's a minimal. You know. The most important thing is the temperature, which is very hard to calculate. Usually we take the last 20 years, 100 years, putting a thermal cell there, you know, and take the average temperature. This is not correct, as you know, but this is the only thing that they have, you know, at hand. It's called to decide this. We have an unknown time. We don't know. Otherwise, we don't need to. We don't have the need to date it. It is given to us, you know, we don't know which climatic curve to apply, for example. So if we know that comes from, say, lower Paleolithic or then by dated by C14, again, there we don't need to apply oxygen hydration because already radiocarbon has been applied. So the temperature is very, very sensitive, and that's why I gave emphasis to that, saying that even 1 degree difference, error, it gives 50% error in age. So we must be very careful. So anyway, I'm coming again to this traditional method, although I have produced my own rods, in order to once for good, you know, to say, are we going to go further with this empirical or just leave it aside? You know, that was the main reason why we did that, and this is one of the trio papers, as I said, which will give an answer to once forever. The other method that we have used, which is the SYMPOSUM, I believe we have to progress, to advance further, and I'm a great believer that that method is independent of temperature. But the problem there, I mean, up to now, is to find funding in order to make, you know, to pay, you know, a laboratory to do SIMS curves. That is the problem. Otherwise, the software is ready. We can make it. Use the software. That was one of my 2 PhDs I had in Rhodos. One is Laskaris, the other is Papagamatriou. So we had 2 PhDs on this method, and we have produced various results. So I think I have the sense that I think we have to move to the SYMPOSUM method and to leave the traditional. But we insist a few of us in the world to reach a net, you know, with this traditional method. At last, if we can use it and at bad conditions. These are promising with the water, which I have shown you. Not bad. Not bad at all. You know, you could see the agreement, but up to now, this is the situation, the status, the art, the state of the art. Okay. Anybody else? Okay, we can go then to the second speaker of this session, which is Kabaczynska and Michalska, electron spin resonance signals in line motors, assessment of their suitability for ESR dating. It is the well-known ESR dating, coupled with the OSL dating and TL dating. It's a well-known technique. Let us see what the speaker will tell us about lime mortars and ESR. The podium is yours.
Good morning. My name is Zuzanna Kabaczynska, and as introduced, I will be talking about electron spin resonance in lime mortars and the preliminary assessment of their suitability for ESR dating. And this research is a part of a project that I recently started at the Institute of Geology at the Mickiewicz University in Poland. that focuses on radiation defects in anthropogenic carbonates. And its goal is to establish electron paramagnetic resonance or electron spin resonance, because both names function in the literature, as a dating method for historical lime binders, mortars, and plasters. We are going to do that through investigating the changes in concentration of radiation-sensitive paramagnetic centers in anthropogenic carbonates that occur with the change of the dose of radiation. And additionally, we are hoping to assess the lower time limit of their EPR dating, so how young the samples can be that we will be able to date. And the first step of this project is the investigation of natural ESR signals of lime mortars that were previously dated with radiocarbon and were characterized. And this is the part that I would like to focus on today. Electron spin resonance, together with thermoluminescence and optically stimulated luminescence, are called trap charge dating methods. And in those methods, by obtaining the dose of radiation absorbed in a crystal in nature, and with the knowledge of the annual dose rate, we are able to estimate the time that passed from crystallization or the last resetting of the signal by heating or exposure to light. And the time range of ESR in dating geological and archaeological materials exceeds 2 million years, but there are virtually no examples of dating carbonates younger than 10,000 years. And those young carbonates, young from the geological standpoint, are the main focus of this project, particularly anthropogenic carbonates in the form of lime mortars. And dating them gives the time of building construction. Mortars are produced by thermal decomposition of limestone and subsequent binding of a new carbonate material, calcium carbonate, through absorption of carbon dioxide from the atmosphere. And currently we have two methods that are used for dating mortars. This is radiocarbon and OSL, optically stimulated luminescence. Radiocarbon dates the moment of hardening of the carbonate binder, and OSL focuses on the quartz aggregate that was added to the mortar during the production process. And gives the date of last bleaching, so resetting the signals by exposure of quartz to sunlight. Most methods, however, have certain limitations, and for OSL, this is the incomplete bleaching of quartz grains, and for radiocarbon, the presence of unburned calcium carbonate and the presence of carbonate aggregate. So we proposed EPR or ESR to date the carbonate in the mortar. And the zeroing moments, the moments that we can date, would be the hardening of the carbonate binder. And for fragments of limestone that were not completely decomposed during the production, it would be the resetting of signals by heating. And this double mechanism of resetting the signal and the potential of eliminating the carbonate aggregate signal through the spectral analysis are the advantage of this approach. That will help to overcome the difficulties that the other methods are dealing with. I should say now a few words about ESR spectroscopy, as I know that it is not as well known as luminescence techniques, but they are all based on the fact that interaction of ionizing radiation with the crystal results in trapping of charges, electrons and holes, in defects of the crystal lattice. Those trapped charges, radiation defects, create so-called paramagnetic centers, which can be detected using ESR by measuring how they respond to microwave radiation when put in a strong, gradually changing magnetic field. An example of ESR spectrometer is shown here. The big round part in the middle is a very heavy electromagnet. And this particular equipment is based in Cluj-Napoca in Romania, where those measurements were done. One of the parameters characterizing an ESR signal is the so-called G factor. Its value allows for an identification of a paramagnetic center. And depending on the symmetry of the crystal field surrounding the paramagnetic center, which can be isotropic, axial, or orthorhombic, the same signal can display different ESR spectra. So when we have a lot of signals that are often overlapping, the interpretation can be quite challenging, especially that it has to be done pretty much manually. But when properly done, it can provide a lot of information about the material structure. The samples used in this research come from 5 different archaeological sites. from ancient settlement of Hippos in Israel, from the burial site in Majorca, a church in Finland, early Christian basilica in Spain, and the royal castle in Poznań in Poland. They were all radiocarbon dated and the data were published. 3 of those samples were a part of mortar dating intercomparison study, MODIS, which gathered the results from several laboratories and compared the procedures and the results, particularly for radiocarbon dating. Preparation for C14 were dependent on the composition of the sample and included crushing, sieving, and in some cases separation of the binder in suspension. Characterization involved petrography, SEM and EDS and XRD. And it's important to note here that those samples were collected and prepared without protection from the light, which normally should be the procedure for ESR as it is for luminescence. And also we have no data on the annual dose rate. So those particular samples cannot be dated currently using this method, but because they are so well characterized, they are a good starting point for the future analysis. Some samples were also gamma irradiated, and ESR measurements were done in Cluj-Napoca at Babeș-Bolyai University in Romania. ESR simulations were performed using an EasySphere software, using the parameters that I previously used in some other works on carbonates. And when measuring ESR of mortars and in general of carbonates, one can pretty much always expect to see manganese there. It has a very characteristic ESR signal with 6 main peaks and 10 additional lines. So in between each of the 2 main peaks, we see 2 smaller additional lines. And in the center, between the 3rd and the 4th manganese peak, there is this area that contains the signals connected with trapped charges. So in datable materials, we should see already in the natural samples, so in the samples that were not additionally irradiated in the laboratory, some signals connected with trapped charges. So I measured the samples that I described. This is the range between the 3rd and 4th manganese, so this interesting region. And pretty much in every case, we can see some signals, some additional signals here, but now the question is to identify them and to tell if they are useful for dating. So we selected 3 samples from those ones, and we irradiated them additionally to see how the signals change. So first sample was the one from Hippos from Israel, and we can see how with additional irradiation the signals grow. I performed ESR simulations, so based on analysis on the spectra and the parameters from the literature, I simulated individual components. As you can see, there is quite a lot of them, and then I added them together to try to recreate the original experimental spectrum, in this case minus the manganese peaks. So we can see that there are carbonates, carbonate paramagnetic centers, nitrates, sulfates, and also an organic radical. And the presence of carbonate signals, particularly orthorhombic CO2 minus, is very encouraging because this is the signal that is typically used for dating carbonates. Also, the nitrate signal has a potential here. So this sample, when properly collected and prepared, could be in future useful for dating. The second example is the sample from Majorca, and here very clearly you can see how the signals grow with the dose of radiation. There is even more components here. There are 3 types, 3 variants of carbonate centers, 2 of nitrates, 3 of sulfates, and orthorhombic CO2 minus and isotropic CO2 minus are the centers that are routinely used for carbonate dating. So again, here this sample has a very promising composition for future dating. And the third example is from Poland, from Góra Przemysła in Poznań. And here the growth with the radiation dose is not as prominent. And this big signal in the center, it's actually connected with amorphous carbon. Presumably it's produced by pyrolysis. So its presence and also the lack of carbonate signals here preclude dating. So in that case, dating this particular sample will probably not be possible. And certainly there will be samples like that, but establishing why certain samples are not useful in terms of like composition, age, production process is also a part of this project. So to conclude, we used ESR spectroscopy for well-investigated and previously dated by radiocarbon samples. And in natural samples, we can see the signals in the interesting regions. And the signals grow with the intensity of, the intensity grows with the dose of irradiation. And the signals that we were able to identify using simulations are connected with carbonate, sulfate, and nitrate centers. The presence of carbonate signals in some samples can be used for dating. It's important to point out here the value of simulations as they allow for separating and quantifying individual components of the spectrum. So then for those components, we can build the so-called dose response curve. And from that, we can estimate the dose of radiation. And the knowledge of the annual dose rate and an appropriate sampling are, of course, necessary for dating. And in the next stages of the project, we will focus on those samples. Some we collected ourselves, and some we will receive from our collaborators. Those were dated by OSL. To test this method. And of course, we are very much looking for new collaborations. We are interested in samples of mortars that were dated or will be dated by OSL, but also with radiocarbon, or in general, just new samples to be collected. So if anyone is interested in that, we will be very happy to hear from you. Establishing ESR as a new method of dating historical carbonate binders will allow us to overcome some difficulties of the currently used approaches. And ESR studies of anthropogenic carbonates will extend the time range of ESR dating closer to the present, which is relevant for ESR dating in general, as it doesn't limit itself only to carbonates, but also some other materials as quartz, bone, and teeth. I would like to thank the participants of MODIS projects, particularly Professor Irka Haidas and Professor Alf Lindros, and Professor Aida Timar-Gabor from Romania, the head of ESR dating laboratory there. And I would like to acknowledge the funding from the Polish National Agency for Academic Exchange and the Polish National Science Center. Thank you very much.
Thank you very much for this interesting, indeed, exercise. Finding the suitability and assessing the suitability of dating mortars by ESR. This is still the beginning, as I understand. I would like to give to the audience the opportunity to, if they have any question, and then I will ask you. I will be at the last. Any question? Dr. Polyimeris.
Thank you very much. I have a couple of questions, short, and if you like, you can discuss a little bit more later. The first one is, you have shown to us that the radical dependent of the carbon dioxide, calcium carbonate, the signal is increasing with the dose for a dose response. Have you established that the hardening of the binder zeros it? Meaning, have you done any bleaching experiments or to make a new binder to irradiate hardly and then to wait until it's hardened and see whether this mechanism decreases the signal? Because I know, for example, in salt, not only heat and light induces zeroing, also friction in salt dissolution. But it is crucial from my point of view to establish first that this signal is indeed decreasing, zeroing, or at least minimizing with hardening of the binder. Do you get my point?
Yes.
Have you studied it?
That will be exactly the second stage of the project.
Okay.
So starting in a month or two for the whole year, that is what we'll be focusing on. We'll be exactly producing new binders in the lab, in the controlled experiment. But, hardening of the binder is essentially producing new calcium carbonate, because it was completely decomposed during heat. So it's crystallization of a new material. So in that case, if a new material is formed, then...
If you irradiate it in a very big dose, you could see at least the decreasing of the signal. Do you get my point? If you get to saturation points.
Yeah, like if it's above the saturation point, yes.
You get the saturation before the hardening of the binder, and then you let it, even even in the secondary calcium carbonate be increased or produced, the signal, if the mechanism still stands, it would be decreasing. And another question, thank you very much, is whether these radiocarbon dates are trustable, because from my point of view, I would have been able to compare this signal with the OSL dating or the OSL signal and check if there is any kind of interconnection between these two signals. Thank you very much.
Yeah, for the comparison with radiocarbon with OSL, so radiocarbon also dates the carbonate as we are planning with ESR. So in that way, through also careful preparation for radiocarbon dating, we are able to isolate the carbonate that was actually produced during the mortar production, as opposed to some that was added, like some older pieces of carbonate. And for OSL measures quartz. So it will actually not be like a comparison of the data from the same material, because in OSL it's quartz, in EPR is carbonate, but actually a kind of independent comparison, independent in that way, but dependent in the way that they will both use the same dose rate data. So yeah.
Another question? I would like to follow up, Polymeris one. I have not seen, probably I missed, did you produce any dose build-up curve of the manganese or carbonate signal?
Not yet. For now, we focus on isolating the components, and then the next step will actually be that. So for each of the components, we want to create a separate dose response curve, and then in theory, from one spectrum, from one sample, we'll have multiple dose response.
So you identified only some nitric, you said sulfuric, manganese ions that could give a signal, and that's it, ESL signal, and you think that, okay, there is a signal, a G value, so I can use it for the future. Up to that point, I mean, it is very, not the preliminary, but what was the problem, to add some doses and to see how that goes up? What was the problem?
To get maybe a bit more technical, the problem is that those simulations, they are basically done each time for like each individual measurement, they are done manually. So there is some uncertainty. So I'm still in the process of refining the simulations. So actually there is a reliable way of estimating the intensity later. But I've done some preliminary research on that. So I do have some let's say, very basic dose response curves, but they are maybe not yet ready to be shown. But the biggest challenge here is the starting point, because at the very beginning in the natural sample, the signals are very weak. So I have to be very precise with the simulations to measure like this very small intensities at the beginning. And they very much affect the estimation of the dose. So even if I get the very big doses right, the small ones are problematic. So it needs a bit more refinement in that way.
Well, although you have started with slime mortars, but I believe that you have been based and you are aware of all the previous works of the ESR, on other materials.
Yes, I actually worked on quartz for a long time.
Quartz and bones, and stalagmites and other carbonates.
Yes.
It has been a huge work, and from Japanese and from Australia, you know that. So you have to not forget, to see what they have done the others.
Yes, that was the starting point. Yes.
Okay, thank you very much.
Thank you.
So next, the third one is, yes, you're here. Portable optically stimulated luminescence, so of POSL, I could say it, as we call PXRF, okay, as a tool for archaeological stratigraphy in Greece. I remember my friend David Sanderson from Glasgow, he had done something about that. Okay.
His picture appears very quickly. All right. All right, so to get right into it, I'll be talking about the use of POSL, and we'll get into what that means. But I'd like to say I'm not quite an archaeometrist. I am a geoarchaeologist. So generally, I'm concerned with stratigraphy. And I see in general, as we increase our methods in archaeometry and analysis of various types of human context, we get back to the necessity for more and more robust understanding of the soils and the sediments and the actual matrix of the site. So archaeological stratigraphy can be very complex. You have human alterations, you have faunal alterations and other bioturbation. And dating can be quite expensive if you're just using dates to sort of establish the sort of sequence of that matrix. Most of us are aware of the expense of radiocarbon or OSL dating, and you can't spend thousands and thousands of euros that you don't have. And this is going to sound like a sales pitch more than once during the talk, so I apologize. So the need for more than just dates in order to secure understanding of stratigraphy. And now we've come to David Sanderson and the method of portable optically simulated luminescence. The machine itself was actually invented to detect food irradiation and then augmented as a portable method for calculating luminescence in sediments. And David himself has done quite a lot of work in developing the method itself for field luminescence measurements. And Tim Kinnaird at St. Andrews has specifically applied this to archaeology, both in the Mediterranean and the British Isles. So we'll move on quickly. I don't think I need to go through this very much, but principle of luminescence, when you have quartz or accumulated dose in quartz zeroed when exposed to a significant, substantial amount of sunlight, starts out zero, starts over again, you sample it, and you can measure that dose. Now, we are not calculating dates, and I want to repeat this over and over and over. I am not suggesting that this is a dating method, or at least not an absolute dating method. With POSL, what we do is we generate as high a resolution a curve across the profile as we can to understand how that curve reacts over sort of a relative time. So we can look at the rate of accumulation. We can look at erosion and hiatuses. We can look at mixing, all important when we're looking at humans living in an environment or altering a site. To do this, it's basically just a very miniature form of OSL method. We go into the field, we take very small tubes. The method that we've been using for the Terrace project, University of Tromsø, is small square tubes so we can stack and get continuous sampling. For our case, we actually do take this back to a fallout shelter, which we use as our modified dark room. And we collect the blue light and infrared data, and then calculate particular intensities and indices. First, for the method, the CW method, which was proposed by David Sanderson. And what we get is something like this. And I just wanted to show how we start. We can just map these out and see how periods can be represented. These are traditional OSL dates. And when you have nice OSL dates, that's the nice thing, is you know that you have a good response from your sediment, so you can do very nice things with your luminescence. And we can map that out against the dates and your histogram. Then you can go to expand through your site to assign these to periods based on the luminescence and the relationship with OSL or even radiocarbon dates if they stratigraphically align. Just the PCA from the same site, which is a vineyard in Italy, just to show that here you have the T1 and the T2 through 4. You can't distinguish the periods from the chemostratigraphy in this particular site, but when we add the luminescence, it's very simple to do so, and it matches very well against our dating results. So I wanted to, the important part of this talk was to show some applications in Greece, and so sort of two very different applications. One from the project that I've just wrapped up with the University of Tromsø, ERC-funded advanced grant Terrace Archaeology, Culture in Europe. and the other from my Marie Curie project at the University of Groningen that's just started last month. So the first site is Hieromandris in Eastern Crete. And for a brief overview, the site, the sort of period of interest for the site is the period of the Thera eruption. The site is a small slot valley just south of the Palace of Zakros. And it's a small valley that goes into a slot canyon with a stream running through it. What appears to have happened is that there was agriculture going on in this small valley. Suddenly there was lots of erosion. The local inhabitants came in, created this complex system of terraces and reservoirs to control the water around the time of, it seems to be immediately after the Thera eruption, completely stopped the flow of the stream. And they seem to have done this based on the pollen and phytolith evidence to cultivate grapevine, probably for winemaking. And we came in for the project precisely to help the Minoan Roads project, Leonidas Vikotopoulos, to understand the geomorphology, the sort of landscape transformations that were happening, and actually try to zero in on the circumstance of the creation of these terraces. So we took our samples, and we find at in most of the sequence we sample, we find this particular hiatus at these net intensity values around 50,000 that we measured. And what's important about this is that where this hiatus happens, this is the stream bed itself. Underneath, we have material dated to the LM1A period. And then above, it's late classical. So there was a stabilization and abandonment, and we don't have redeposition in that area until quite later. Now, at this same threshold, we have the accumulation of the terraces, and we can be a bit more specific because we have this bulk of inherited or presumably inherited values here, which seems to be inwashing. So the terrace walls were built first to control the erosion, and then later we have a more smooth signal from plowing, reworking, or the addition of soil. So we took a few hundred measurements from this site, I think over 300. And many of them here we have mapped out against the ceramic and architectural chronologies established for the various deposits. And of course, as we understand with OSL, when we're taking these measurements in the field or we're taking them in the POSL method, we're not doing a lot of the processing to remove things like micas or organics. And so we will, and we're not doing too much to sort out for the grain size, except for removing everything larger than coarse sand. And so we do have some things that should not quite be where they are, but some have an inherited signal. Some perhaps just younger because they've the grain size issues but in general, what we do see is for this terrace accumulation, it happens at the LM1A, 1B boundary, and this OSL signal corresponds to this cultural chronology signal. And luckily, all of our identified pelesols fall earlier. So for something perhaps, POSL tends to be pretty good at landscape level questions anyway. The question becomes, when we get to something more disruptive, more archaeological, more localized, do we have any utility? This is Aios Vasilios in Laconia. This is a cemetery, mostly the middle Bronze Age, some late Bronze Age, associated, predates, but associates with the Mycenaean palace, Aios Vasilios. And the cemetery is under the direction, excavation under the direction of Sofia Vutsaki, who is supervising my project there. And been working for a few years, and we had samples from a few of these graves. Now, these are micromorphology samples. So from the blocks, I cut chips and kept them dark, and then we ran them using the standard protocol on the OSL. POSL. And we chose two graves, one that we knew was undisturbed and one that we knew was disturbed, to see if we could detect that. So in this particular grave, which is a simple cyst burial, relatively shallow, when we were looking at this microstratigraphy, we identified these sort of lag deposits resulting from looting and reopening multiple times. And if we look at the signal, we see significant and constant reversals and disruptions, which even spatially align with the evidence that we have for the disruption. In this undisturbed grave, where we took a sample, just again as sort of a demonstration, at the floor of the grave, and we do see a difference between the soil beneath the grave and the soil above the grave. Unfortunately, that was all I was able to get because it was excavated very quickly, and I happened to be in a different site the week they found it. So I like to repeat again, this is not an absolute dating method. However, we cannot be overcautious, so overcautious with looking at the applications of OSL and the worry that people will take it as dating, that we ignore the fact that taking large volumes of luminescence samples allows us to a much more elaborate and complex and elegant look into the formation processes of a site. There are admitted issues, and if we acknowledge these issues, not only do these issues become something we can mitigate, but we can actually look at the issues and understand some of them as features or benefits. For example, you don't always know when something's completely zeroed, but if you start to see something that has a lot of inherited signal, that's a geomorphic signal that can be used to describe the environmental history of the site. The advantages are obviously the cost. The machine is in fact relatively cheap, and you have to pay a little bit extra for the training, but then you get to spend a week with David Sanderson, and that's not so bad. And it adds the more and more as we advance in methods, we need to stop relying on more simple field observations of our stratigraphy or ceramic stratigraphy. Even geoarchaeology needs to advance, and something like this, which is semi-quantitative, which is robust, which allows us to do a lot more than simply distinguish between deposits, is certainly the way forward. So I'd like to thank my colleagues at the University of Groningen and at the University of Tromsø. I'd like to thank the conference organizers for helping me come here with the Early Researcher Award. And lastly, I'd like to thank all of you for listening to me. Thank you.
Thank you very much for your presentation. I think, is there any question? Left side, middle, right, Polimeris.
Thank you very much. I agree that in general, I agree with you. I could not agree more with two facts. It's not a dating, absolute dating, and it's fun working with David, definitely. So let me ask you, I want a technical question. The instrument doesn't accommodate irradiation, correct?
Right, yes. So you can correct, there's a few ways you can deal with that. Particularly, we always work alongside Manex susceptibility and PXRF. And PXRF, you can do sort of a quick and dirty calculation for your dose just by ratioing in the potassium.
Okay, but you don't irradiate. You don't have any strontium yttrium source for.
Oh no, there's nothing. It's just a blue light, an infrared light, and a photon detector.
Without any heating.
No heating. It's just light stimulated.
Because I am aware of another projects from Italy, for example, that because they are trying to heat at the same time, they have some big problems in the background system. Thank you very much.
There is another portable. There are 3 portable systems for luminescence, and one of the other ones does in fact allow for heating, but this one's the SURC model does not. Yeah.
Any other question? So the combination of susceptibility measurements and XRF may I say, could substitute, this portable luminescence could substitute in the information regarding the information that we get with XRF and susceptibility. You get all this profile, disturbances, anthropogenic changes or natural changes with two methods. So could you tell us a few words more? What is the added value of portable luminescence, added value in addition to the information we get from susceptibility and PXRF, which are, as you know, very portable and easily and immediate, we can make measurements.
Certainly.
Your comment.
Yeah, I can. It's very simple actually. It's the time dependency is far more reliable in luminescence than what you get in magnetic susceptibility or in a chemostratigraphic profile. Both of those have time factors, and because magnetic susceptibility with various factors like microbial action and general soil formation, which also impacts the PXRF. These are things that do in fact, and we do in fact calculate time in certain soils on sort of vague terms using soil formation formulae. The problem here is that these are not entirely reliable and they're dependent on almost invisible environmental factors. So the luminescence adds a slightly heavier weighting in the direction of time dependency and actually allows you to sort of cross compare and see if you're seeing something that looks like it's something that's time dependent. And whereas you can go in the other direction, in fact, and use the PXRF and the magnetic susceptibility to sort of zero out some of those factors that would affect the luminescence curve as being more time reliable.
Yeah, this is, you said you can get an idea of time dependence of these measurements. That would be a wishful, I could say, expectation, since other factors take place in these luminescent signals like fading and
yeah, and that's why you use magnetic susceptibility, PXRF, and POSL together, because they in fact they're not all vulnerable to the same circumstances.
Thank you very much, once more. Thank you. Do you have contact with David?
Sorry?
Do you have a contact with David?
Yes, occasionally.
Give my best regards.
All right.
Thank you. And the last talk of this session by Vafiadou, Laskaris and Polymeris, Obsidian Hydration and Luminescence, Edges of Archaeological Interest from Greece and Turkey, and Obvious Hiatus within the 4th millennium BC.
So, good afternoon. I will try to keep it short. 2 comments before the presentation. I will not be presenting new data. This is a lazy work that we did about collecting previous work data, and I will have to apologize because my emphasis will be given in luminescence, even though my colleague Nikos Laskaris has contributed to the obsidian hydration dating. So there is a slide indicating things that have been dated so far by our group or in general. Let me give you some rudimentary stuff about luminescence. What can luminescence date? Everything that is heated, ceramics, pottery, porcelain, bricks, flints, kilns, solidified lava, everything that has been exposed to light, sediments, wind-blown soils, anthropogenic, fluvial, lacustrine, blah, 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 and other archaeological artifacts using the surface luminescence dating, masonry, megalithic buildings, monolithic, rock art, and mortars, at least in general. So, starting from the thermoluminescence in 1950s and the optically stimulated luminescence in 1990s, a combination of stimulation using heating only and or either light can result in many other type of stimulation and stimuli and stimulated luminescence forms. And why? Because in general we try to expand. You see here archaeomagnetic paleomagnetism. These are the limits of the technique. Hardly up to 1 million of years. So we try to expand not only below the upper, but also beyond the upper, also below the lower. Okay. So when I first realized that when I returned back to Greece and took the laboratory of radiocarbon dating, I realized that there is a huge repository and database about all published radiocarbon dates of archaeological interest, not only from Greece and Turkey, but from all over Mediterranean. Okay. So I took it over and tried to work with it, and I realized that a similar database, including ages obtained from stimulated luminescence or obsidian hydration dating, is not available, especially in our region, Greece, Turkey, whatever, Mediterranean. Okay, this is exactly what I tried to do. So the idea was to collect all the ages that have been either published or reported. And who did this publishing and reports? Professor Leregis, Nikos Zacharias, other Greek luminescence scientists. This consists of 55% of the total number of ages. In the National Calibration Secular Curve for Paleomagnetism at the area of Greece, including 22% of the total number of ages. And of course, other luminescence scientists reported many ages all over the world, 11% of the total number of ages, not to mention that 12% of the presented ages that I will be giving you today come from obsidian hydration dating. Okay, so I ignored the calcium carbonate luminescence dates produced by Georgia Fordakos because they are in calcium carbonate materials, and I would not like to be in mixing them. So we try to collect. This is a typical Excel reference, lab code, what technique was applied, what's the material, the age, the error, the location, the region, archaeological period, and some comments about whether the error and some technical issues we included. And this is the map about the majority of, I'm focusing on the area of Greece and Turkey, okay? And I am just focusing on the ages that have archaeological interest, meaning I don't include geological dating of the geopaleomorphology of the sediments in Greece, in Turkey, or whatever. So only 650 ages, only, including luminescence and obsidian hydration dating, much less compared to the overall 5,000 radiocarbon ages reported. 5,000 were then, today almost 7,000, okay? Why is that? Because probably archaeologists do not trust luminescence. Almost 7 additional ages were calculated, but have not been reported yet. 3 future projects from my laboratory, at least, will include datings from Polyochni, from Andisa and Kaviria. You can see here, yellow pins corresponds to OSL ages, red pins to TL ages, OSL, thermoluminescence, obsidian hydration with orange, and white pins include dates from cave. If you could see that we have, for example, from Polyochni or from Plissura, ongoing research, because these are not published yet, we will be published then, so probably we will be expanding a collection, not a database, it's a collection, okay? So this is a, but you can see also that there is a lack of dating from central Turkey, okay? And you can see a detail about that of the Greek area and Asia Minor. What really makes a good, what really impressed me is that we don't have any literature age reported from Troy, like what is supposed to be ancient Troy, okay? So it doesn't matter, maybe if you find anything, if you see that probably ages are missing from this collection, okay? If you find anything, and just remember me, just send them to me, I can include them. So if we try to plot these ages as a number, and you can see starting from the younger to BCE, here stands before current era, okay? Before today. But we not use before present because a typical terminology we use in radiocarbon dating. So you can see that it's there is some kind of hiatus here, and this is the well-known hiatus, meaning 4,000 before Christ and 3,300, okay? You can see that the majority of there is some kind of discontinuities here, but you can still have Strophilas, Kythnos, Turkey, Polyochni, Kumula, and Dimini dates. This is the well-known hiatus of transition from the late Neolithic to the early Bronze Age, at least in the northern part of Greece, which is very well known. We can see it also here in in a very limited number of 650 ages from Greece and TL. 20% from Turkey, the rest of these come from Greece. You can see that the majority of the samples come from North Aegean and Central Greece. And you can see that if we try to distinguish and categorize the ages depending on you see here is the maximum age, again, before current era, Macedonia, Turkey, Macedonia, I mean the Greek Macedonia, okay? Central Greece, South Aegean. You can see that in Macedonia, in Central Greece, in Peloponnese, and in the North Aegean, there is this hiatus still here, but it is not in Turkey, it's not, Turkey is shifted. So in general, you can see that there is a localized effect of this hiatus in Greece. It is the same case that it was highlighted by the radiocarbon ages, okay? You can see here that you can see that 500 ages are just published just for North Greece, okay? And you can see the hiatus here, just radiocarbon, and this is the first settlement in very close to Thessaloniki. So, what can we date? What was dated? Pottery, kilns, stones, obsidian, clay, brick, tiles, burnt flint, and sediments, and other, including frictorious soil, mortar, volcanic slugs. Nikos was the one. I did not include, as I told you, geological dating, except TLOSL ages from my PhD from the Santorini, from the Pylos underwater area, which direct date the Santorini volcano. OSL ages from cave sediments because they direct are extrapolated to a historical occupation. And a very recent one date that we are trying, a methodology, that we try to date the soil underneath the monumental olive trees in order to date and expand this age to the olive tree itself. And this is our very latest paper reported, but I don't know whether we will include it or not. So the majority of the ages correspond to early Bronze Age, final Neolithic, and the others, then we have late Byzantines. It is quite interesting to note that 45% of the ages reported are in agreement with the expected archaeological age, 27% underestimated, 28% were overestimated, 30% were calculated with better accuracy than 9% error, and 13% were calculated with worse than 20% uncertainty. It is important to understand that the Mediterranean area, Mediterranean Sea, has signified a big number of milestones in luminescence dating. And since we are trying to honor the memory of Nikos, it is important to say that Nikos was the first one who tried to do mortal OSL dating and metallurgical slugs using TL. It was the first one. The first publication, the pioneer, go directly to him. Of course, Yannis here is the first one who did surface luminescence dating and keeps practicing it. All of us keep. TL dating of karstitic monuments by Yannis and Georgia Fordakos, even though some problematics here. Pioneer characterization studies, not dating, of obsidian hydration by Yeter Göksu in Ankara, 1975, the date I was born. She was trying to do obsidian hydration dating. Pioneer studies on authentication of marble sculptures by using TL by Polykreti and Maniatis. Typically, if this methodology has been used by the research by people from Denmark and tried to expand it nowadays. Pioneer studies of ITL dating techniques by Athanasas and Pagonis. Of course, I would like to say that we are trying with Professor Kittis to expand dates beyond 1 million of year and implementation of machine learning approaches to stimulate the luminescence by me and my group, which is a very recent one. Many milestones, and I'm just limited to archaeological ones, okay? There are many, for example, archaeological in the area. For example, our colleague Mina Vafiado is the first one who dated Egyptian monuments from with using luminescence. So it's still a collection. We want to make a database including all the aforementioned ages in order to be able to use all metadata available. Include ages of geological interest maybe as well. Combine these ages with ages from other techniques like radiocarbon, expanded archaeomagnetism, and have a universal ages database from Greece, Turkey. Expand this database to a wider region, starting from the Levant, Italy, and then to Mediterranean. Of course, make this database available to all relevant scientists via our website at my laboratory in Demokritos. So before thanking for your attention, I want to say that this presentation was meant to honor Nikos Zacharias because I found him working, when I started working in Luminescence, I found these two people, Liridis and Zacharias. I want to say to you that keep trying to date things, no matter what's the technique, and whatever you need, just contact me. Thank you very much.
Thank you very much, George, for this excellent management, processing, I would say, and illustration of this metadata. It is a necessary tool, and very cleverly, it was conceived by you and your co-authors, because as it is proved, you can tell us a lot more information that from the first glance one could not imagine. So, that's very important, and keep on doing this database. Thank you. Any question? No questions? Thank you once more, George. Dear colleagues, I would like to tell you that we don't have any coffee break, but we keep on following the next session, the 11th session, building materials, with chairperson of Yannis Iliopoulos. Thank you for your attention.
So we reached the final session of this excellent conference, and we'll continue with the first contribution for this session. So it is co-authored by Anne Vlavé, Burkhardt, Fragnoli, Proceska, Zweinger, and Welte, and is titled Exploring the Life Cycle of White Marble Artifacts, from Coring to Production, Usage to Provenance Studies, and Digital Archiving.
Good morning. I'm not sure if you can hear me or
yes.
if...
Yes, Anne Vlavé, the floor is yours.
Thank you very much. I would like to thank the organizers for giving me the opportunity to present our project of the last years, and which is related to exploring the life cycle of white marble artifacts and from production to the digital archiving. Just a few words about our material collection here at the Austrian Archaeological Institute in Vienna. We are dealing with many material groups, but also archaeometric analysis, including ceramics, mortars, glasses, pigments, lithics, and today I will present you the specific case of the white marble and with some extensions of limestone and other stones. As in many projects that they are dealing with analysis, of course, we have to follow a very, to us, clear circle with planning, collecting material, processing them at the laboratories, analyzing them, preserving the information, sharing all the new information and data with in academic world, and of course, be able to reuse this data that they were produced within these projects. Just a few words very quickly. What is marble? It is a metamorphic carbonate rock, and we have two types, calcite and dolomite. And after ceramics, it's one of the most widespread material from prehistory till nowadays. And we find it in many uses and purposes, such as expression of art, architecture, construction, expression of religion, and many, many other statuses. So what are we doing? We want to find out the provenance of this material, where this material is coming from, and by knowing the results of the fingerprint and origin of these stones, we can then answer questions related to social and economic status of its community. We learn more about the technological knowledge and the development of the different periods, and of course, we research the ancient trade, which could have been done via land, the river, or sea routes. And we can also ask some more practical questions, such as conservation and restoration of ancient buildings, and of course, authenticity of the materials. Starting with planning, this is just a general map of the Eastern Mediterranean and different quarries that we have in our database. And of course, planning the next steps, we have to find where to target which regions. And of course, we realized that in the case of modern present-day Bulgaria, we don't have much information. And by zooming in this region, we found out that they have many, many different cities and are mostly focused in Roman period. And of course, an extreme amount of local marble white sources. And this is how the project was planned, which was run by 2020 until 23. And it was named Fingerprinting of White Marbles, Quarries and Cities in Roman Thrace between the 1st and the 3rd century AD. It was financed by the National Funding Agency of Austria. And the target and the aims was to record the white marble quarries in ancient Thrace, with a special focus in inland Thrace, the characterization of the marble and the trade, to investigate the Roman economic models, and of course, by having all this information, then to combine the new data and publish them further. So how this, moving on to after we established the funding and the team, of course, we had to collect the material. COVID killed us a bit with 1 year delays, but we were able to have a pilot study between 2018 and until 2019. And then after the many COVID regulations, we were able to return for 3 more sampling campaigns between 2021 and 22, which meant that after all these 5 campaigns, we were able to collect 1,500 samples, which around 1,000 of them are archaeological artifacts and 500 of them are quarry samples. And then, of course, more struggle started with the laboratory work and, of course, the evaluation and the interpretation of the result. This physical collection that we brought from Bulgaria here, of course, had to join the physical collection of our institute. Without having a comparison database, we cannot have clear results. And here, in the very new establishments of the Austrian Archaeological Institute, we managed to have a room as you see in the photos of the physical collections, which counts more than 9,000 geological samples from all over the world, and in addition to 5,000 analyzed artifacts. And these are collections joined by many, by the Institute itself, but also the kind donations of many colleagues. Of course, the question is how to do this digital and sustainable, but I will come back to this at the end of the presentation. We are lucky, again, here, since 1 year, we have new establishments in the center of Vienna, and we have a very new laboratories that we are happily using for this procedure and our laboratory work. Of course, it comes with a problem. It's a destructive, this provenance studies is a destructive technique. We need the samples. And when it comes, as you see in the photo, into geological samples, it's not a problem. We can have as big samples as possible. But in terms of archaeological material, we have to be very careful, take a very small sample and be sure that we will not disturb the historical and archaeological value of the object. We perform a set of various techniques. Since marble is a very homogeneous material, we need many analyses to be able to have the secure results, including microscopic, macroscopic and microscopic observations, petrographic analysis, if the sample allows us to prepare a thin section, if it's big enough, stable isotope analysis of oxygen and carbon, chemical analysis, we do ICP-MS, and we are able to detect a various set of elements, and fluid analysis with ion chromatography. And since the session is called building material, I would just like to show you only very quickly one example. This is the theater of Philippopolis in modern Plovdiv, Bulgaria. It is all made of white marble. It is a very beautiful masterpiece of architecture, and we were able to analyze approximately 50 samples of this material, and this is how our multivariate diagrams looks like, including all the analysis, all the data that I mentioned before, and we were able to establish that this city and this theater is coming from local marble, which is called the location Arsenovgrad, and it is approximately 20 kilometers from the city. So we know that the city had active quarries running mostly 2nd and 3rd century AD. As you see here, we have one Berkovica and one Prokonnesos samples. Berkovica is also in Bulgaria. Prokonnesos is in the Marmara Sea. We later established that these samples, these artifacts are not belonging to the theater, but from buildings surrounding it. So again, we can confirm that the theater is made exclusively of local material. Continuing, after having everything, of course, we try to collect all the information. As you see, we have the sample information, the description of the marble, the analysis, different numbers that related to the sample itself, museum numbers, laboratory numbers, a small description of each artifact, the locations, the photos, where it's located now, the geography of it, and all the institutions that they are related within the sample. And the same goes to the quarry sample. We have, again, the description of the marble, all the numbers related, all the photos. And here we have a different situation. We have the quarry, which is a description and coordinates of a specific location, but also a quarry group, which means that maybe one region has many different groups or pits, and then we are treating them as a group with having combined results. And of course, again, we have the geography. We refer to the analysis, where the analysis was made, which are the numbers related, and which type of analysis happened to every sample. And again, the institutions that they are involved. In that case, for example, we have the Austrian Archaeological Institute, the University of Leoben, that we did the ICP-MS analysis, the University of Wyoming, we did the stable isotope analysis, and the Technical University of Vienna. And as I mentioned before, of course, our main target was to publish all this material because it is quite new, and these areas were never investigated before. within these research questions. And our target is also to publish open access. So with supplementary material, so these data are available to everybody, and except of the journal websites itself, you can find our papers on academia and ResearchGate. But the question always remains, and now what? What do we do with this? We have endless columns of material and data, and we have endless lines of numbers. And how can we proceed? What does this helps us in the future? So within this project, we managed to create an online database, fingerprinting white marbles, which targeting to preserve and combine all the data, geographic data, images, archaeometric analysis results, and bibliographies related to every object, and have it access to the public. Of course, the question is how to maximize this use and how to have this website and this database as sustainable as possible. And of course, we had to make sure that this database is linked to other related databases, such as the OIDAM, which is our digital asset management system, and OIMAC, which is the magazine archive and the physical collections. However, realizing soon enough that the FWM was not enough for the team, so we decided to go big or go home. And by going big, we renamed the database to the OI Metrics, and we decided now to apply this prototype of databases for many other databases, archaeometric databases as well. The database itself is a Django-based application and Python-based web framework. And the plan is that now people do not need to calculate extra money from their project budgets for databases. The model is there, the model is available, and we don't have any more small individual databases that after the project, they're dying, they're just floating online with nobody to continue the work. But we make sure that within the metrics, we now can have it sustainable and keep running it for a long time. How does it look like? Very quickly, just you see here, we have the different information, and you can click what do you want to see. For example, the grain size or the colors or the artifacts, you can have this control. Of course, there is also a question, what do we do with the closed data? All our data are going there, and the open access, as the moment that our publications are open access, at the same moment, all the data are becoming available on the website as well. And of course, there are linked to the image database, but we have the artifacts, we have the quarry samples and many images from each location, each quarry. And more specifically, we have images of from the petrographic microscope of our thin sections. And other links and other databases that they are connected to ours is the Zotero, which includes every bibliography, every reference that we produce, but also where quarries or other artifacts are referred, and they are linked to every single individual entry. And of course, we have the OAI Thesaurus material, which is our vocabulary, control vocabulary system. So the user, it is a user-friendly application when checking, for example, for a specific word. This is control and not very chaotic and can get direct results. As I mentioned before, the aim is to make it sustainable. We have we try to have a very friendly, a user-friendly application. You can see here we have the artifacts. For example, now it's 1,100. The different numbers related, the quarry groups, the samples, the projects, and this is a continuous work that we keep updating every week. And we have also a visualized network diagram that you can click on top of this bullets, and then you can find directly the information related to what you are looking for. To conclude, this will be an ongoing project, hopefully for as long as we can keep going with the marble studies. Please visit the website. It has been running only since June, so we are very grateful if you have feedback for us or suggestions or any corrections. And the next bigger issue, what we are working at the moment, is the Roman quarry and the marble presence in Austria, and specifically in the area of Noricum, which is again an area with its own marble supplies and of course a very strong white marble Roman presence archaeologically. Thank you very much for your attention, and please, you can always contact us for the database here at our email, and of course, if you come to Vienna, I would be very happy to show you around our new laboratories. Thank you very much.
Thank you very much, Ms. Nevlavi. I would say a massive collection and an excellent approach.
We're trying.
Unfortunately, I was in Vienna, but I couldn't manage to.
Next time.
Last week. Next time, yes. So, are there any questions? Yes, please.
Lovely talk. It was really interesting. I don't do stone, so I do apologize, but the open source database, is it just for marble or other stones, or can it be transferable to any other assemblages or artifacts? Because one of the things for my PhD is I want to create an open source database, and I'm not very tech handy, let's say. So I'm just interested if this is transferable to other artifacts and assemblages.
Yes, it is absolutely transferable with any artifacts possible. At the moment, we have the same application for ceramics. We are working on the same application for lithics, and we are having also the same application for numismatics, for coin collection. So it doesn't have to be extremely archaeometric only, but it can be also archaeological. And that was the general idea, that colleagues from the Institute, but also collaborators from outside the Institute, could be able to use this format for many things.
Thank you very much.
Any other question? Yes, Professor Zini?
Δεν ακούω.
Yes, just a moment.
Can you hear me now? It's Eleni Zimi. Χαίρομαι πολύ που σε βλέπω. Congratulations again. Vasiliki was one of our first students who dealt with archaeometry. It's the second after Vanna Orfanou. Vanna is not around at the moment, but she's outside. But we are very, very proud of her. This is a wonderful work. And of course, archaeologically, it will contribute immensely in several questions, and not only in those related to characterization and understanding better the different type of marbles, but I'm thinking also of ancient economies as well, and especially Roman economies. And it would be probably an idea to get connected with the Roman economy project, because of course Thrace was a terra incognita, I think, so far when it comes to marble. So thank you for that. And just a very quick question. We know that Romans had this tendency of bringing marble from very far away. Is this something that you are looking at? I mean, how much of this marble was imported? Was imported not just from places which were in vicinity of Thrace, like, for example, Marmara or Thasos, but from very far away. Thank you.
Thank you. Indeed, yeah, I started in Kalamata many years ago, and now I have white hair. So concerning the marble trade, it is in the case study of Thrace. We haven't been able to evaluate every sample, but our biggest example is the Roman Philippopolis, which we have more than 300 artifact samples from the city itself, including architecture, sculptures, inscriptions, and every type of marble object. We so far have seen that Thrace was sufficient enough. They had their own supplies. So they had no need to bring the material. For example, in Philippopolis, we have almost zero colored marble entering the city. It's mostly white marble used and mostly local. The architecture itself, it is almost 90% made of local marble with some excluded material, mostly luster capitals or Corinthian capitals for decoration purposes, which are coming from Proconnesos. And what we show, totally different image, is that the sculpture trade, we have more imported than local. We have a big local workshop, absolutely, but at the same time, within the 50 sculptures that we analyze, 26 of them are made of imported marble, and imported we have from Aphrodisias, we have from Göktepe, we have from Dokimeon. So we see this very large trade network from very far, and surprisingly no Thasos, which is really trouble us because Thasos is just below. But so far we haven't seen Thasian material. It could be explained that the demand of Thasos was too much that could provide material to Thrace, but this is something that we are still looking at.
Thank you very much.
Are there any other questions? So thank you very much, Vasiliki.
Thank you very much.
Pleasure.
See you soon.
Then we can continue with the second contribution, co-authored by Manzana, Zimi, Pololi, Kageli, and Tiliopoulos, and it's titled Mosaic Floors from a Roman Villa in the city of Chalki, Serbia. First results on material identification and provenance of some stone tesserae will be presented by Manzana.
I use this one. Okay. All right. Well, good afternoon. I'm Eli Manzana, and I will present you the first results of our research on the stone tesserae of mosaic floors from the city of Chalkis. Before I start, I would like to thank the organizing committee of the 8th RKRNT for the opportunity to talk about our research. The present work is focusing on Roman mosaic floors of Chalkis, the capital city of Euboea Island, a city with long history that during the Roman times experienced a period of prosperity. Among the archaeological findings, there are mosaic floors with sophisticated decorative techniques and interesting stylistic approaches. Today, only 3 of them are remaining in situ, and the rest are stored in storage rooms, like the one that we are going to discuss today. Well, 5 mosaics of the Roman villa at Chalkis were discovered during 1958. Records from the process are very limited. The mosaics are decorated with various geometric patterns, but at the central theme of room E, figures with animals, theatrical masks are presented. These 5 mosaics were removed from their original position in the late 70s. and have been stored in uncontrolled environment for almost 45 years. Of course, these are very bad news for the conservation, but for archaeometry means a lot of samples. In 2022, a restoration program started and new supporting layers were constructed for the detached mosaics. The floor of room E was the first to be completed, and during this process, a number of discarded tesserae and mosaic fragments were collected. A selection of these materials are the samples that we are going to analyze. Birds, hunting scenes, and theatrical masks on a white background, all framed by a tight woven three-color gilos, are distinguished. The tesserae are in most cases less than 1 square centimeter in size and much smaller in the areas with more details. Polychromy is also present with 6 colors and distinguished with various other colors, but glass tesserae. The samples of our research represent the color palette of the repeating pattern of the mosaic floor E, and this choice is based according to the available fragments. The analysis of the samples was carried out in 2 laboratories. The analytical techniques are focused on the mineralogical identification of the stone materials and the analysis of their morphological features. In addition, the use of portable Raman aims to evaluate the contribution of the technique on stone materials identification. Finally, the preliminary provenance study attempts to compare the red tesserae with well-documented red stone from Eboea. Here you can see 29 of the available tesserae samples. As you can see, we had almost 5 tesserae from each one of the colors documented: white, black, gray, yellow, light red, and red. The samples are prepared into powder sections, thin sections, but also we used the original surface, the top surface of the mosaics, of the tesserae. The mineralogical composition, according XRD results, show a predominance of calcite for the white, black, gray, and yellow tesserae. For the white tesserae, all the diffractograms are almost identical and show only the presence of calcite. It's very characteristic. Calcite is also the dominant mineral in black tesserae, but quartz is also present. Exactly the same minerals are, and the same observation can be made for the gray samples. For the fourth group, the yellow one, again, calcite and quartz are distinguished. On the red and light red tesserae, ankerite and dolomite are also detected. The light red tesserae are divided into 2 characteristic groups according to the presence of these 2 minerals, ankerite and dolomite. For the red tesserae, calcite, quartz, ankerite, and dolomite are present in all samples, and a small difference in the amount of quartz can be observed between the first and the fourth sample. Now, the petrographic observations are presented according the 6 color groups. The first case of the white tesserae is a sedimentary biomimetic limestone rich in bioclast and peloids. The homogeneity of the samples is obvious, confirming the results of the XRD, and the origin of the black tesserae from the same type of stone. Sorry, I have missed something here. Sorry. The homogeneity, again, in black tesserae is obvious, as you can see in the three different tesserae. And let's go to the next color, the gray tesserae. They are so the same morphological features in all samples. The specific type of stone presents areas with gray peloids, but also veins of calcite, sometimes in large crystals. The case of yellow tesserae seem to be divided into two different groups of stones. One is micritic limestones, and the second one is calcitic sandstones. For both of them, calcite is the dominant mineral with a small amount of quartz. The photomicrographs of the light red tesserae also show two different types of stone, a micritic limestone and a very fine sandstone with calcite as the dominant mineral. On the other hand, the petrography of the red tesserae displays a coarse-grained sandstone with large fragments of calcite and quartz with calcitic cement. Based on the last tesserae, this red type of stone could have various granulometries and a more complex stratigraphy. In general, the results of the petrographic analysis seem to agree with the result of XRD, but this method allows us to identify further characteristic examples and also to understand how many different type of stones we might have with the same mineralogical ID. Our work is trying to focus on the Raman technique. Given its portability, which allow us to do in situ analysis, we are trying to evaluate whether the technique can be efficiently combined with XRD and petrography. In the case of black tesserae, for example, we can distinguish different types of spectra from analysis from the three types of samples. And for the case of yellow stones, different compounds of minerals are detected in at least half of the samples. For the identification of the findings on the blue spectra, in the second case, further investigation needs to be done in the future, but we can suggest the existence of two different types of yellow stones. On the other hand, the comparison of the spectra of the three types of samples for the red and white tesserae show no differences. This fact could be explained by the clean surface of the tesserae, but especially for the red sample, we have to underline that the lack of that we observe the lack of ankerite and dolomite, minerals that was obvious in XRD results. But let's go back and step back from the stone tesserae and look again at the bigger picture, focusing on one of the most famous red stones of antiquity. Marmor chalcidicum was the name given by the Romans to the stone quarried 20 kilometers south from Chalkis, next to the town of Eretria. Known to Greeks since Hellenistic time, it was not only used in the two cities of Euboea. This type of stone was exported to Rome but also is present in Pompeii and Herculaneum. Its appearance is quite uneven, with white, reddish, pinkish areas, sometimes with irregular brown patches that often crossed by white veins. Professor Lazzarini research is crucial and provides valuable information of the distribution of findings all over the Roman territory. The sampling of the stones for the provenance study was carried both on Roman quarries, but also in the modern part of the quarry, which is closed since 1980. Based on the initial observation, the 3 samples, 4, 5, and 6, were chosen for analysis. From these 3, number 6 is considered to be the most representative for the red stone of Eretria, and I will try to focus my presentation in this one. The X-ray diffraction analysis reveals the difference in mineralogical composition between the 3 samples, and the number 6 presents mainly calcite and small amounts of quartz and albite. The petrographic analysis presents 3 completely different types of stones, with the last sample to be recognized as a micritic limestone rich in bioclasts that consist mainly by ammonites and calcitites, radiolarians. I will not say that, radiolarians. Okay. According to Lazzarini, this compact white-veined red limestone with abundant microfossils is considered as the source rock or protolith in which primary sedimentary characteristics are preserved. Based on Raman, for mineral identification for this inhomogeneous rock, we can underline several advantages due to the possibility of distinguish and analyzing very specific domains, crucial for the in situ analysis. According to the results, we can locate areas with hematite, the domains with larger amounts of quartz, and others with great amount of calcite. But are such analyses sufficient to study the provenance of the red tesserae from the Chalkis mosaics? Well, by observing the XRD and Raman results, we can mention some differences between the samples of red tesserae and the red stone of Eretria. For example, the presence of fankerite and dolomite and the absence of albite from the red tesserae of sandstones, or the presence of hematite only in Fiordipesco samples. Furthermore, the identification of minerals and morphological features is obvious by comparing the photomicrographs of these 2 cases. The observation of the thin section show the difference in morphology between calcitic sandstones and biomicritic limestones, without leaving any possibility that the red tesserae could be made from the Fiordipesco. Well, until now, for this research, which has just started, we can underline some useful inclusions. First of all the stone tesserae samples are coming from sedimentary stones with carbonatic minerals. The white, black, gray, and red groups are the most homogeneous samples with identical petrographic characteristics and mineralogical composition. Petrography played a key role in the identification of sandstones of the red tesserae and biomimetic limestone of white and black tesserae. The light red and yellow present at least two different types of stones and require further analysis. The Raman spectroscopy provides useful information about the two types of yellow stones. And the use also of Raman spectrometer seems to be an effective analytical technique for mosaic preserved in situ. An important parameter for the in situ Raman analysis is that the upper surfaces of the tesserae should be free from deposits. Last, the combination of analytical techniques, petrography, X-ray diffraction, and Raman spectroscopy provide useful results for the identification of stone materials, both in the field and the laboratory. This preliminary research clearly show that famous Flor di Pesco was not able to be the material for the tesserae, at least for the pavement E of the specific villa in Chalkis. The question is started with, how did the mosaicists of the Roman era handle and use these construction materials? Were these craftsmen able to buy the materials for their mosaics from an organized trading system, or did they have the knowledge and resources to mine them locally? In this case, if this is the case, then our research should focus to identify sedimentary stones around Boea, for start. And our question is still the same: which road the stone tesserae of the Roman mosaic floors were traveled? At the end, I would like to thank my colleague Dimitris Mitsos for his help with the Raman analysis, as well as all the colleagues of these two laboratories. Our collaboration over the past 3 years for me was very important. Thank you for your attention.
Thank you very much, Ellie. Are there any questions? So maybe I can ask, what is your opinion about why they didn't use the Fior di Pesco, or why we don't find it in the mosaics? Do you have a first?
It's very soon to have a conclusion about that, but because I have a small experience to construct mosaics and work in stones to create tesserae, the specific stone, it's quite metamorphic. It's something between. It's very hard, and you cannot use it. You cannot form easily square cubes. These cubes. So I think it's one of the most important reasons. But since it's a well-known red stone, documented and through history, it was very important to have information from this source for the beginning of our research.
Yes, but for sure we'll need more raw materials.
Yes. One more detail is that since now we have seen the tesserae from ancient Messene, and also all of them are sedimentary rocks. Nothing in metamorphic.
Okay. Thank you very much, Ellie. We can continue now with the last contribution for this conference and this session. It is co-authored by Elisabetta Agliozzo and Antonio Pizzo, and entitled Technological and Provenance Investigation of 3rd Century BC Plasters from the oldest basilica of Tusculum in Italy. And will be presented by Elisabetta Agliozzo. Elisabetta, the floor is yours.
Okay. Thank you. So let's start saying where Tusculum is for the non-Italian people. We are about 25 kilometers southeast of Rome in the area that is called the Alban Hills. And the site was inhabited beginning from the 5th century BC to the 12th century AD. And during the Roman period, it became the place where the aristocrats of Rome, the VIPs of Rome, were used to buy, to construct their villas. You know, it's 670 meters above sea level, so you have fresh air and far from the crowded Rome. Also, Cicero had his villa here in Tusculum. During the excavation led by my co-author, which is Antonio Pizzo, who is the director of the Spanish school in Rome, during the last excavation in 2020 and 2021, they excavate the area number one, and they discovered there, which was interpreted as the most ancient basilica in Tusculum. And it was dated precisely to the end of the 3rd century BC. So we didn't have a dating issue in this case. During the excavation, in a total of 3 stratigraphic units, so in a very concentrated place, they find all these architectural fragments that you can see in the image. And all these stratigraphic units were related to the single activity, which was the construction of the wall. At that point, I was asked to analyze them to understand which raw materials were used, how these plasters and mortars were realized and applied to the wall, and where were the raw materials sourced. So I sampled something like 17 samples of mortar plasters and a couple of samples of cociopesto, and I analyzed them through optical microscopy, SEM, electron microprobe, X-ray diffraction, ICP-MS, and thermogravimetric analysis. The results. First of all, the first results I got was about the stratigraphy of this architectural fragment. It was possible in this way to reconstruct the entire sequence. This is the first layer, and I will begin from the outer layer going to the inner one. So this is the most superficial one. And it's a quite strange layer because it's made by spherical site in a lime binder. Only this. It's only calcite, it's not marble. And also the lime binder was made of between 93 and 97% of calcium. The interface with the second layer that we are going to see, it was quite irregular, and I thought there were presence of interaction between the two. So I thought that not a long time passed between the second and the first layer. The following one was entirely made of lime, so it's a pure lime binder layer, the second one. What's interesting that it was applied over a very regular surface, and you can see the surface here. This is correspond to this interface here. Just over the third layer. And what was interesting is that this interface in places were coated by a yellow pigment, a yellow ochre. So that meaning that for a certain time, the third layer was painted, so it was visible in that way. Then what they did was to scratch it with parallel grooves and then applied the second and the third. So I'm going in reverse order compared to the history of this. The third layer is, from my point of view, still quite strange in a way, because it's made by only two kinds of components. The first one are lithic fragments, and the second one is the lime binder. Usually in mortar we find sand. No, there is no sand in this. There is no sand in this mortar. Just the lime binder and a series of lithic fragments that are very clearly distinguishable also from a microscopic point of view, because as you see, they are all black. So black lithic fragments. And the mineralogical assemblage of these lithics are made of leucite crystals and clinopyroxene. Iron oxide minor components, and sometimes also magnetite is there. And that can be classified as pumices. The fourth layer, so the one underneath, is similar in a way, because we still have only lithic fragments and the lime binder, but what it changed consistently are the type of lithic fragments. As you can see from this macroscopic image, they are not anymore all black, but they are all red. Okay. And also the dimension of these lithics change because they are much bigger than the black ones. And despite the fact that the mineralogical assemblage is still the same, because we still have leucite and clinopyroxene, the proportion slightly different. So we have a little bit more clinopyroxene than in the black ones. But still, only the aggregate made of this kind of lithic fragments only, and then the lime binder. Then we have the fifth layer, which instead is different, because we still have the same lithic fragments of both black and red, so before, but now we have also fragments of chamotte. In a way, it's very similar to the underlying layer and last layer, which is the coccio-pesto one, which differs only in terms of dimension of chamotte. So in the fifth layer, they are still larger, but not so much. With the coccio-pesto, chamotte can arrive up to 7 or 8 centimeters, so very big blocks of ceramics inside of it. So these are all the layers. And so if we go instead in the historical sequence, so from the oldest to the newest, they started with the coccio-pesto, then they applied the fifth layer, so mixing both chamotte and lithic fragments. Then they had a first thick layer. It was about 8 centimeters thick of lithic fragments of type 2, so the red ones with the lime binder. Then another layer about 2 centimeters and 2.5 centimeters of lithics type 1, so the black lithics and the lime binder. And at the end of this phase, they painted the surface. So it means that for a while, the wall was decorated in this way. Otherwise, they wouldn't have painted it. But at a certain time, they decided instead to revise, in a way, the finishing of their wall. They applied a thin layer of lime, and then the last finishing with the crystals of a spherical site. This is the reconstruct sequence. So I would say that we have 2 main phases. Now, one until the third layer, and then the last 2, that is a later finishing. The thermogravimetric analysis showed that We have, of course, based on previous works, we can say that the binder of the second layer was non-hydraulic, while the binder of the third and fourth layer were hydraulic, and the binder of the fifth was highly hydraulic. So they have the most of the big, thick layers made of volcanic lithics had hydraulic properties. So once reconstructed the sequence and understood what kind of material that they used, what we wanted to know is where they supplied those materials. I started to better investigate the lithics in the third and fourth layer, because they are the most interesting, and also they are all the same. Doing just areas, compositional areas by the SEM, I saw that they have a fluiditic composition. But at this point, they were not, it was not possible to discriminate one from the other, just have the information that they were fluidities. So I tried to understand, of course, which could be the sources for fluidities in the area close to Tusculum. So we are here, okay, close to the, so Rome is here, and we have the Pozzolane Rosse, the Pozzolane Nere, and all the yellow, the area colored in yellow corresponds to the Pozzolanelle. Of course, this was one of the possibilities, but, and you could say also they were red and black, why not the Pozzolane Rosse, so the red pozzolanas, or the Pozzolane Nere, which are the black pozzolanas. Actually, most of the pozzolanes are or red or black or gray or yellow, brown. So the color actually couldn't discriminate so in a straightforward way or certain way. Also, we had to consider also all the, because we are here, so in the Alban Hills, but other possible sources were in the northern part of the Roman magmatic region, so in the Vulcini, Vico, and Monti Sabatini. Also, they could have imported the pozzolanas from the Campanian area. So we don't know. We had to test which one of these sources was supplied to do this, plasters and mosses. So what I did was to mechanically separate the aggregate from the binder and analyze them separately by ICP-MS. In that way, I was able to compare with the reference data that are provided in the literature, especially from the group of Marra. And I saw that there was not good comparison, for instance, with the Campanian volcanics. Only by this part, but also from a mineralogical point of view, we can exclude the Campania area as a provenance, as a supply for this lithics. Then I try to compare with the northern part of the magmatic Roman area, and I saw that there was actually, especially for the red lithics, a comparison was slightly reliable, both with the Vulcini and Vico, than with the Sabatini mountains. But the problem at that point would have been mineralogical, because if it was from Vulcini, Vico, or Monti Sabatini, for instance, I would have found also sanidin, biotite, so other kind of minerals, while our lithics contain only leucite and clinopyroxene, doesn't have any other phase. So there was a chemical comparison that could fit in a way, but mineralogy did not support it. So I arrived to compare with the Pozzolane, which are the closest source of this kind of lithics with respect to Tusculum. And I saw that there was seems a joke, but actually the Pozzolane Rosse fit very well with the red lithics, and the Pozzolane Nere fit very well with the black lithics. We cannot exclude actually the Pozzolanelle as another kind of as another source, even though the comparison, especially in some elements, it's not as robust as for the others. So it seems really a joke, but at the end, the best comparison we found it was for the red lithics, the Pozzolane, the red Pozzolane, and for the black lithics, the black Pozzolane. So what we get from all this, of course, from the stratigraphy reconstructed, actually what we see is something quite rough, because if you measure the thickness of the various layers, you find a very thick, we have something like 15 centimeters of plaster put together, which from a static point of view is not the best, of course. You usually try to do something thinner, not as big as that. So because they have hydraulic properties, the only idea that we have is that they really wanted to insulate the building. That's why they regard to such a thick and also elaborated kind of plaster. But you see, this is the decoration in which these architectural fragments were used. If you consider 15 centimeters of plaster on it, you think that it's a little bit too, just rudimental in a way. Technology is really packed. But it's evident that they had great problems of insulation, of impermeabilization of the structure. Another question that I made to myself is why they do two layers so similar, actually. From a technical point of view, it's not easy to find a clear explanation for that. The only consideration that I can do in this case is that the black pozzolanas, that we now refer to them, are very heavy, while the red ones are much lighter in weight. So this could be the idea that they wanted actually something thick to insulate well the structure, and then but they couldn't do everything with the black ones because they could have been too much weight on that. So they just distinguish in two layers using two different, one lighter and one heavier material. This is the only idea that came to my mind, because technical reason there aren't. So, or of course they didn't see also, because at the end it was covered by other layers. So I don't know what else I could think about this. The last layer, it's very peculiar and very interesting from my point of view, because it's one of the very early occurrences of this kind of finishing. For later periods, we know very well, especially in the Venetian area, that it was called the marmorino. So it was something, it's a very precious kind of finishing that was made to render the surface in a very brilliant way, because of course the surface of the crystal, of marble crystal in that case, even if they were crushed, they were sparkling. So they create a sparkling effect to the wall. In this case, actually, it's very rare. I don't know other occurrences in the 3rd century BC of this technique. So this could be one of the very early occurrences of this. And it's worth reminding that both Varro and Vitruvius mentioned this technique for two different reasons. So Varro suggested to use it to deter vermin, while Vitruvius suggested for this sparkling effect that it was able to confer to the wall. From my point of view, what is even more interesting in all this is the fact that before this basilica, the utilization of the Roman of the Pozzolana of the Roman area are not attested elsewhere. So this is, for the moment, as far as I know, the oldest occurrence of the use of this Pozzolana in the Roman area. If you see the list of all the analyses that have been done in the Roman monuments, you can see that all three types were used, but in a later, at least 1 century later. And this tell us the first occurrence, but also in which way they were dealing with their territory. That's the interesting information from my point of view, because they knew where to find this material. They want exactly this material. They selected this material because in natural deposits, it's not possible to find all those. They were selected, maybe sieved, to get all this fragment approximately of the same dimension, same color, say. So it was a selected material, choiced. So they choose exactly that. And they knew where to go to source them in a period in which only the Campanian Pozzolana were used. So maybe there was a technological transfer in a way. So people that came from Pompeii teach the Romans how to exploit them, or they just experiment and find that they were suitable. But in any way, it's interesting to understand that after a while that Pompeii were using consistently in their monuments, also Rome tried to exploit their own sources. Thank you very much.
Thank you very much, Elisabetta. Are there any questions? I would say that it's very interesting because we have noticed same Pozzolana, Nera or Rossa in tiles, in some of the oldest tiles that we analyzed from Roman Forum. So
Yeah.
it's very interesting. This.
Yeah, the use of these materials
yes.
is.
And what was a curiosity of mine, this the grog, the samot that you analyzed, it seems peculiar in composition, photographic composition, or no? I see no volcanics.
In Cociopesto, in the Cociopesto, and there are fragments of bricks, actually, very big, very thick, and no, the composition of Chamot, no, it was quite, yeah, standard, let's say.
Okay, there are more questions? Thank you very much, Elisabetta. Thank you very much. If I can have only a minute to say that a very successful meeting is being concluded in a while, and this is thanks not only to the very important contributions from all the researchers and also from many younger researchers, but also it is due to the remarkable work of the organizing committee. Thank you very much for all this preparation. And only two couple of words that the lights, dear colleagues, dear friends, will go off soon here in the room, but certainly the light in our souls will remain, the light that is emitted from Nikos Zacharias. He will always be present there in our minds, in our souls, with the light emitted by his smile and his kindness. Thank you all very much.
Ladies and gentlemen, dear colleagues and friends, as we come to the conclusion of the 8th Symposium on Archaeological Sciences and New Technologies, I would like to take a moment to reflect on what the event represents. The symposium, which was initiated by Professor Nicola Zacharias, has grown into an important platform for the exchange of knowledge and ideas in the fields of archaeology and cultural heritage, and is truly heartening to see it continue to thrive. Let us make an honorable mention to the online poster award to Mrs. Tsupra for her work on Playing with Dirt, a geoarchaeological study of clay and tempering materials from East Crete. If she is online, she can make a statement, but if she's not.
Yes, I am here. Can you listen to me?
Just give us a moment. Yes. Congratulations, Ms. Chopra. Mrs. Doctor, I'm not sure. I didn't have a title.
No, doctor yet.
Okay.
Thank you very much. And thank you very much. And this poster is part of my PhD work that is about raw materials and is in progress. And I am still getting a lot of results. Thank you very much.
Thank you. At this point, we would like to invite Professor Eleni Zimi, who is now the director of the Laboratory of Archaeometry of the University of the Peloponnese, to give a greeting. Professor Zimi will also have the honor to presenting the award of the best poster.
Dear colleagues and students, dear friends, ladies and gentlemen, as Vaya mentioned, I'm Eleni Zimi. I'm an associate professor in classical archaeology in the department here in Kalamata. And I was confided this role by the rector of the university just 2.5 months ago. You would probably wonder how a person who is not a scientist is in this leading position. My background is in archaeology, but as is known, it always takes time for the person who is in archaeological sciences to take over this position, which for so many years was held by Nikos Zacharias. So it seems that I'm setting sail in a journey that I'm not quite sure what to make of it yet. It's challenging for me, but also something very interesting and very, very exciting. It's for the Laboratory of Archaeology, this is going to be a transitional phase. I don't want to see it as a transitional phase. I intend to look forward and work with the lab team and the external partners. Nikos endowed our department with a very well organized and competitive laboratory, both in terms of equipment and in terms of remarkable young scientists. His vision was exceptional and his legacy in archaeometry most valuable. We will do what he would wish us to do. Keep calm and carry on the innovative scientific teamwork, enhance synergies, and open new paths of thinking in the constantly evolving field of archaeological sciences. Concluding the 8th R&T, I would like to congratulate the organizing committee, and especially Vaya, Eleni, Celia, and Gabriela for their endless hard work. Also, I would like to thank the Greek Archaeometry Society for their support, and above all of you for participating and presenting and sharing your current research in this conference, which pays tribute and celebrate the life and works of Nikos Zacharias, an exceptional colleague and a constant scientist. I look forward to welcoming you in 2 years' time for the 9th R&T, and this time in the university premises here in Kalamata. Thank you all for the participation.
The best poster award is awarded to Panagiotis Kaplanis for his work on the Greek-Albanian archaeological project on the islet of Maligrad in the Great Prespa Lake through the modern technology of 3D models. Panagiotis. Yes, of course.
Okay, thanks. I didn't expect that. I want to thank the organizing committee for the effort and the patience, responding all my emails and trying to understand what is happening here. I've never been in this environment. And this collaboration was made by 3 friends. This is an NGO that they created back in 2006. 3 friends with the common goal of cooperation is the Institute of Trans-Balkanic Cultural Cooperation. We're trying to understand what is happening in Balkans. Now we're working in Albania, and I would like to invite each and every one of you to come and work with us, because we need you. We don't have a lot of money, but we would like to invite you to work with us and help us understand more. And Albania is an amazing place. If you haven't been, come join us and let's work together. Thank you.
Before I proceed to the next award, I think we need to thank also Dr. Nerajis Dragic, who of course did an enormous amount of work for the organizing committee, even if he was not in Greece. So it is an honor to also welcome PhD candidate Maria Kilafi, wife of the late Professor Zacharias, to present the Nikolaos Zacharias Young Researcher Award, a recognition of the outstanding contribution of young researchers in the field to Dr. Dan Falou, for his work titled Portable Optically Stimulated Luminescence as a Tool for Archaeological Stratigraphy in Greece.
Well, just a few words. I'd like to thank all the organizing committee for this exceptional symposium. And I'm happy, and I'm sure that the next symposium will be held in Kalamata in 2026, and we'll be glad, we'll be grateful, and we'll be very happy to have you all here, and new participants, and new works, and new researchers. And it's an honor, and I'm very glad that we will award Mr. Falou for all his work and for all his ambitious research. And we will know that he will go on. So.
I would like to ask Dr. Eleni Palamara for her kind statements.
Thank you everyone for being here this past 3 days. It was a great honor for us to organize this 8th and obviously most emotional and difficult conference. Now for the practical and scientific stuff. As most of you know, we had the great pleasure of publishing the proceedings of the 7th Archarentei in a virtual special issue in the Journal of Archaeological Sciences. Just for the record, let me get my notes. We had over 50 papers submitted with a publication ratio of about 60%. So the final issue has now 32 published papers. I urge you all to visit the papers. They're free online in the website of JAS Reports. The publication time was approximately 6 months. And for the proceedings of this conference, we will continue the collaboration with the journal, and we promise that we will make sure that the publication time will be even smaller this time. We want to have all papers that are going to be accepted published in 3 to 4 months maximum, because we all know how important this is for you all. So you're going to receive the detailed instructions about the publication process within the next month. Please give us just a little bit of time to regroup before we do that, and expect that the submission period will be early 2025, early spring 2025. Okay, so we hope that we will see all of your contributions, and that we will have an even greater and nicer volume for the proceedings of the 8th Archarentei. Thank you all again for being here these 3 days, and thanks to the people who were attending online.
Well, that means that we have to get our research together for such a short submission period. I know that everybody is tired from the last 2 days, but I want to take the opportunity to have the organizing committee come up. Dr. Neragis, Dr. Georgios Rigas, the PhD candidates, Celia Valadou, Dimitris Mitsos, Gabriela Logothetou, Eli Majana, the ones that are here. The ones that are not here, we thank them for all the work that they did from a distance. This would have never been able to take place without their help. They're constant. Yes. And Ms. Skilafi, of course, I'm sorry. Maria. And please, all of our volunteers, our wonderful MSc students, our undergrad students, please come to the front so you can also take a picture. They are and very patient with us, no matter what we tell them. Agile. So finally, we extend our special thanks to our sponsors, our co-organizers, the Hellenic Society of Archaeometry, under which the auspices of this event took place, the symposium. We thank everyone that came from far away, everyone that was online, all of you. We thank our photographer, who is always close to us, Nikitas Kotyaris, Mr. Economo and their technical team, everyone. Thank you so much. And we will see you again in 2026.